very serious when you are recording.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is, now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming and saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and other things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and other things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people.
Good morning and welcome to the third day of talks at EuroPython. I also like to welcome the remote viewers on Venulus. Our first speaker today is Lukasz, and he's going to tell us how to embed a Python interpreter in iOS. Please give a big round of applause to Lukasz.
Hi, welcome to Snakes on Airplane Mode, or embedding Python in iOS applications. I usually say I'm Łukasz, I come from the internet, but since Ireland is essentially a Polish colony right now, like I'm from Poznań, which is in the western part of Poland. I invite you to visit, it's nice. Back in 2019, I went to London to give a keynote about how Python should not only be used for data science, it should be used in more ways, like this Pew Pew console that I was using back then. I got it from Radomir, and in fact, you could use it on this very conference at a workshop earlier in the week. But I also talked about like WebAssembly, which is happening now, and like mobile devices, which we're gonna make work now as well. So what do I mean by, actually embedding, and why do we even want this? Like, this talk is going to go through all of this. We're gonna begin with just, kind of appreciating Swift, the language that iOS developers do use for development as a kind of first-class language. Then we're gonna say, like, okay, so if you have Swift, then like, why would you even want Python there too? And if you want it, like, how would you actually make it to build so that Apple will be fine with it running on an embedded device, on an iOS device? And if you already have it compiled such that it does work, we're going to talk about like how to actually use it from within the iOS app. And finally, we're going to actually run some code for you to actually believe that this is all actually practically useful. Before we begin, like a question I already got asked at the conference, since this is the last day and we've been here for a while, like it's like, why would you actually want this? The App Store like has Swift, it had Objective-C before. So sure, like Objective-C has been with us since '84, and it's been used for iOS applications, like, pretty much like from day one when the SDK was released. It's been the language of the year in 2011 and 2012, and this is because of iOS. Like back then, there were like 750,000 apps in the App Store, which ended up paying out over $7 billion to developers. So, it was like 2/3 of the market for mobile applications were iOS. So everybody was like crazy about Objective-C. Only later they found out, when they were actually trying to make those apps, that they crash a lot, and it's kind of awkward to write them because the syntax is very unfamiliar and whatnot and whatnot. So Apple saw that they're hitting a wall with adoption through Objective-C being kind of like a legacy language. They tried to kind of make it more modern with Objective-C 2.0, with garbage collection that was later kind of deprecated because it worked kind of lousily on mobile devices. But it turned out not to be the way. So they released Swift in 2014. And like 4 years later, it already overtook Objective-C with adoption. So like apparently they did something right. Like it was the most loved programming language dubbed by the Stack Overflow Developer Survey in 2015, and second place in 2016. Clearly only possible because Python was struggling with the 2.2 to 3 transition then. But still we have to give it to them that, most loved programming language. And Redmonk.com says that in a world in which it's incredibly difficult to break into the top 25 of language rankings, let alone the top 10, Swift managed the chore in less than 4 years. It remains a growth phenomenon. Okay, so clearly they did something right there. But obviously, when we're looking at this chart, we're mostly interested in this. We're at a Python conference, we're the first here, like, yes, language of the year, 2007, 2010, 2018, 2020, 2021, and good chance of doing it again for 2022. In fact, like the top 4 languages there like have like nearly 50% adoption. So, kind of, we're there, we're winning. So maybe we should just upseat, Swift and just kind of start doing mobile applications that way. Well, I don't believe that. I think that Swift, as the language of choice by Apple and made kind of the official platform tooling, is always going to be better than using something that is third-party and tries to play catch-up and make stuff magically work on multiple platforms. Yes, there are multiple options for this. There's React Native, there's Flutter, there's Beware that the Python community is working on. But I personally, just my personal opinion, think that you should be using the best tool at your disposal. So why do we even have this talk then? Well, because I'm a heavy note taker. I have thousands of notes on my phone, they're synchronized on my Mac, and I do a bunch of things with them, including publishing my website. And there's a bunch of automation that I do all the time. And I'm able to do it on the Mac because I just run the EuroPython, but I cannot do any of this on the phone, and it's annoying because I already have those Python scripts. Usually they're not even NumPy, natural language processing stuff. It's just regular, boring Python that uses the standard library, and I still cannot use this. So I found that there was an app on the App Store that allowed me to use Python to model workflows like IFTTT, and kind of write small scripts. But it turns out this was Python 2, and this is no longer maintained, so it was kind of a bummer. I saw what is this developer doing now? So, oh, they're doing Pythonista. This is an entire IDE that is running on your phone where you can do mini apps and kind of run them within Pythonista, but they can be graphical, they can interact with the operating system, you can have widgets and whatever. It's okay, that's cool. Also not maintained for 3 years now. So I was looking at an alternative, and Emma Cole worked on, and still works on, Pyto, which is sort of like Pythonista, but actually maintained, and pretty powerful. On the website, you can see, that it allows for running Python 3.10, which is awesome. An actual modern version of Python. You can run this. It includes NumPy, Matplotlib, and whatever. This is paid, which I kind of agree with her. This entire Pyto app is open source, so you can kind of download it and, try it on your own. But if you want to have, include libraries and a bunch of other things, this is a paid on the App Store. The reason why is that if it weren't the case, you would have tens of copycat apps that do exactly the same, and then it's a support nightmare for the actual author. So open source is kind of we want it, but at the same time people don't play the game fair all the time. So the fact that part of it is paid is good by me. But plenty of awesome features. But again, this is not what I wanted. I just wanted a text editor to be able to automate it. I didn't want to write my text editor within Python and just run it as a Python mini app. That's not what I wanted. Back when my haircut was quite different, I actually was saying that Python is runnable pseudocode. 13-year-olds can program it. So this is what I wanted to do, to let people write Swift apps that are modern, that are first class on iOS, but allow users to extend them, to customize them, right? And is this something that anybody is doing? Well, as far as I can tell, not on iOS, but in the world of desktop applications, that is a tremendously popular thing to do. You have Blender, right, which is kind of industry-grade 3D modeling software, and it has a Python API, right? You have Bespoke Synth, a modular synthesizer that can be scripted with Python. You can just make it play notes generatively and whatever. If you're a YouTuber or an aspiring YouTuber, you know OBS, and that thing can also be scripted by Python. So all of this is pretty popular. In fact, even production-grade digital audio workstations like FL Studio here can be programmed with Python. So clearly the market is there. People want this, since supporting multi-platform Python embedding is not an easy job. So the fact that all those pieces of software, industry-grade pieces of software, not toys, actual professionals use them, the fact that they want Python APIs there means that this is something that the users are actually wanting. So, should we actually unseat Swift? No, we should make Swift talk to Python and, the vice versa. So this is what we're going to do next in practice, in live, because we live dangerously. We'll be using Beware's Python 3.11 for iOS scripting, so kind of setup. since Python 3.11 does not build cleanly on iOS. I wish we're not there yet. We will be there at some point. I do hope to work with Beware to make 3.12 pretty much compile for iOS with no changes. So we'll see. As a developer in residence, I think I'm well positioned to actually make this happen. We'll be using PythonKit to talk from Swift to Python and vice versa. That was originally created for Swift for TensorFlow. That was an attempt to replace Python in TensorFlow with Swift. And this is now a project that was canceled. So clearly, again, use the best tool for the job. Turns out that Python is the best tool for orchestrating machine learning. Swift tried to unseat that, didn't work. But we will be using Swift UI, which is the kind of latest and greatest in creating mobile applications for iOS. The fun fact about this is that there's not going to be any Objective-C inside. So before we actually look at code, Beware. Beware tries to make Python applications run on mobile in ways where you write a single code base and you can run it on Android and on iOS with pretty much no changes. And there's also like a Linux port, so you can run it on desktop as well. We're not going to be using Beware today. We're going to be using like a support element of Beware, which allows to Python, the programming language, be built in a way that can be embedded inside an iPhone application. So what is this Python Apple support thing? Like, why do we need it? Well, it is a gigantic patch file that makes tiny changes to, many tiny changes to Python, such that we can actually compile it with Clang on Xcode and make it embed. But it's also like a make file that is like 1,000 lines long that kind of provides like a ton of steps that have to be made for the actual artifact to be acceptable by Xcode. So with having all this in mind, demo time. Cool. So, before we begin, let me show you something cool. All the things that we're going to be doing in memory, because I have 64 gigs, so why use disk? So let's switch to RAM disk. CPython, no, we're not going to be working on CPython now. I mostly have it to run CPython because you can compile it in like 8 seconds in RAM. But now we're just going to clone an app that I wrote in Swift UI. We're going to talk about it in a second, so let's go there. See what we have here. Okay, so let's just open this Bullseye Xcode project. Okay, we have an Xcode application. It is a very, very simple Swift UI application. It's got an app object, which you can see that there's literally just some state, we call it a game, and there's a single content view, like a single window and a single sheet for like a leaderboard. So like very simple. There's a bunch of views, but it's only because, it's like in HTML, you have a bunch of components that are like just nested inside one another. So we're just switching them, like, splitting them into multiple files just so that this file, the main file, doesn't look terrible. In Xcode, you can actually see the preview of it. So let's wait until this builds, and in a moment we should see. Yeah, this is like the smallest thing you can call a game. So it's like put the bullseye as close to the number 19. So you literally put the slider as close to 19, click hit me, and like if you got 19, you get like many points. If you got 90, you're gonna get less points because it wanted 19. Yeah, so like very simple application, but it already this is Swift UI, so it's proper iOS, so like it works, in both orientations. It will work in dark mode as well, which we can actually check here, like by switching to dark, and back and whatever. So yeah, like all of this kind of works very nicely. This isn't even the simulator. Well, you can obviously run the entire application in a simulator. I have my phone connected. It's called Lucky 13 because it's an iPhone 13 mini, and I'm lucky because minis are just well shaped for my hands. But now let's just use the oldest device that can actually run this. So a simulator of iPod Touch, which I don't believe they sell anymore, but it is what it is. So this is going to take a while, and then the simulator is going to hopefully show us something. It doesn't show us yet. Okay, so we can, kind of attempt to, 14 maybe here, I don't know. 15. Okay, so we got 149 points. Awesome. And now we're in round 2. We can do 5. So 5 is going to be closer. Okay, 5. Oh, 200 points because perfect, bullseye. Amazing. That was not scripted. That's just my talent. Yeah, so it has like a leaderboard. Obviously, it's stupid. You don't log in, you don't do anything, but it just shows you there's a card that you can swipe out. It's this is like a modern Switch UI app. It doesn't have many lines of code. You can reset your progress if you don't like to have many points. You can just start over. That's the thing. That's the app. It's not very complicated. What we will want to do is to replace this logic that calculates the points with Python, right? So this is what we're going to be doing. So let's stop the simulator. In fact, before we even do anything else, let's try to run it on the phone so that I'm sure that actually it does run, because it would be awkward in a minute if it wouldn't, but it should be fine. So build succeeded, and it says running, but can we see it? Well, I hope we can. Look, this is my phone from QuickTime Player, so you can actually see me manipulating the phone, right? And it actually does a thing. To prove you that this is actually the phone, this is the phone. Hinek, don't message me now. Yeah, actually, I don't trust him not to do it, so let's put focus, do not disturb. Okay, yeah, so this is my actual phone, and we're running this app, right? So it's a pretty nice developer experience. We're gonna put Python there. The reason why I'm so insistent on oh, look, this is the UI, this is the simulator, this is the device, is that all 3 steps fail running Python in different ways. So I can show you that we can actually run it in all 3 scenarios, which is important if you actually want to develop applications later. Okay, so let's stop the application right now and put our Python thing in it. Oh no, this is too small. So let's just change to this directory where I was before, which was this. Python Apple support. Let me show you what's in it. I see it on the wrong screen, but here it is. So it's essentially this make file and everything, and it has a bunch of distribution files that we will be literally dragging and dropping into our Xcode project. So let's do it right now. Oh, or maybe not. Let's create some folders so that we organize things as civilized people do. So frameworks. So we're going to put the frameworks that we built. And also resources, we're going to put the standard library of Python. So, boom, resources. I can barely see it, but okay, hopefully no typos. So frameworks, and we want to put those XC frameworks there. There's a bunch of them. It's kind of weird, but I'll explain it in a second. So we're putting it over frameworks. We do want to copy them inside. If you do that, then GitHub wants you to pay them because now your kind of .a files are going to be very big, and this is no longer free tier of GitHub. So welcome to professional development. This takes a little while to compile because it's oh, I don't know what this is. It'll resolve it in a moment. In the meantime, we can add the standard library of Python, which is in this Python folder. You see resources, lib, Python 3.11. We also want that. We will be using that. So let's add it to resources. Okay. And now, after all those question marks disappeared, we will experience Xcode lying to us many times. This is going to be a story of failure, but I want you to actually see these failures, because if you actually skip a step and end up seeing this, I don't want you to just see the final solution first. I want you to see the failures so we can actually know oh, this is how this is solved. So now we put Python there. We don't use it yet at all, but does it build? We pressed yes, and it says it does build. It will say that it cannot run it because I have my phone locked, but I unlock it, and now it's running. Let me switch to the simulator later. In fact, I want to do it because I want to show you that Python is not at all there yet. So let's switch to iPhone Touch ID again. Press play. Build succeeded. Awesome, it shows. Cool. How can we see if it's there? There's multiple civilized ways to do it, but we don't have time for that. So let's see it in the simplest way ever. Xcode allows you to see the build folder in Finder. So we have the build folder again in the wrong screen. Let's bring it here. This we don't need anymore. And you see that, oh, there's a Bullseye app. It has like an icon that suggests that it won't run on this computer because it's an iOS app. But we can look inside and we see that the Bullseye thing is 700 kilobytes big. Okay, cool. But the Python parts, which are like, yeah, the headers we don't need, lippython.a is 70 megs big. So if your application is 700 kilobytes, you can pretty much know that nothing happened. Like this was actually not included. Like it's not good. By the way, you can see that those headers, they are needed for Xcode to show us things, but what's actually linked is this .8 file. So clearly we have to fix something. So well, we should make sure that there's a framework that is actually like included in this app. So is it included? Xcode claims it is. It listed under frameworks because we put it, in a nicely called directory, and it looks like a framework, so it lists it. It says do not embed. We actually don't want to embed because what that would mean is dynamically loaded libraries would be embedded inside our application. We have .a files. They should be linked with the binary. That should end up like a single code object. So we don't want to embed. That's fine. We want to link. Do we link it? In build phases, we should see link binary with libraries. And they're all listed, so they should link. But they're not being linked. Why not? Oh, it turns out that I needed help with that from Corey Benfield. If you look in that project, you'll see like a lot of headers, so like all those .h files, and among them, the main one that we want is python.h. If you open it, it will say entry point of the Python C API. This is what people include when they want Python. So we actually do need to say this to the Swift compiler that like, hey, this is the .h file that you need to look for to embed. So let's make a new file and create a module map. Where's an empty file here? Empty. I just want an empty file. Give me an empty file, please. Oh, empty documentation. Markdown. Close enough. So let's put it wherever. Say Bullseye and call it module.modulemap. Okay. Yes. Not Markdown, dude. Oh, still Markdown. Okay. We want to have a module called Python, and that module will have an umbrella. That's a nice keyword. I like that they have a keyword called umbrella. Header, python.h, right? We just look at it. We want to export everything from it. We're greedy. And we want to link Python. That's it, but we want to put it in a good place. So let's show this in Finder. There's more Finders. I want to see all of them. Okay, frameworks. So those headers need this module map. So let's give it the module map. What is happening? Okay, let's copy this file over here. By the way, all of those things are the things that I hope with 3.11 are going to be just automatic. But for now, if you want to actually use this for the next 2 years, like this is what you have to do. So this already will run on the device, hopefully. It's a lie, but like, you can hope. And then we also have to make it work on the simulator. By the way, what's fun, you'll see that the simulator's lib.a is twice as big. It's because it's a fat library which runs on both ARM and Intel. So that's good. The device one doesn't have to have like fat binaries because it's only ARM. Okay, so with this in mind, like that should already fix our problem, right? So let's try to run it, stop the previous one, run this one. Build succeeded, it did appear, and this is still 800 kilobytes. That's not good. And the reason why is that the Swift compiler tries really hard not to link things in if it's not entirely sure it needs them, because otherwise mobile apps would be terribly big, and nobody wants to download hundreds of megs over, kind of their data roaming in a different country. So we actually have to, in our app, say import Python. What's this Python? Well, that's exactly this thing that we just defined, this module that we just defined. and we actually have to use it. So we have to define some fake function called please link Python. And here we need to use some part of the C API, like py initialize, say. Like it's how you would initialize like a Python interpreter with the C API. What does this say? Please link Python. Oh yeah, of course. Cool. So in a minute, like this should disappear. Okay. Now let's try again and see some progress. Oh, progress, errors. That's good. That means like we went somewhere further. What are those errors? There's hundreds of them, but among them you will see that there's like stuff, oh, SQLite is missing. Why didn't viewer add it? Well, because it ships with iOS. You don't have to actually add it again. Like it would be wasteful. Again, your binary would be bigger than it needs to be. So when we link stuff, we just need to say we want SQLite. In iOS, we ship a SQLite version. So let's add it. And let me just already, libz is also needed. So let's add that too. So yeah, TBD, by the way, not to be determined. It's text-based description. Also didn't know what that is. I asked Apple people, and they said text-based description. Now we're smart. Okay, cool. Let's try it again. Both succeeded. It runs. And now, 12 megs. Still smaller. It's weird. Because the Swift compiler is actually smart, and like within the binary, there's a bunch of like debug symbols and stuff that actually does not link to python.h. So we're not, in fact, linking those, but we're linking Python now. So this is success. Now we actually have Python inside our simulator. So we can start doing stuff with it. But what we have right now is this import Python thing that exposes the C API of Python, which is super low level. You have like stuff like incrementing and decrementing reference counts and whatever. Like this is not really what you want to do if you're writing in a high level language like Swift. So instead, what can you do? There's a bunch of things for Objective-C, but again, we don't want to use Objective-C. And there's one cool thing for Swift called PythonKit, which originally came from the Swift for TensorFlow project. So we can add it by just saying we want a dependency. You can also use CocoaPods or Carthage, but like let's just do it like graphically here. And you say from GitHub, I already have this here, but you know, it's like this entire link here, just add PythonKit. So you just paste this entire link here and say add package. And now conference Wi-Fi will allow me to add the package. It did, which is amazing. And we can see that there's already some code there. It's some cute like Swift code that does the thing that we wanted, which is like converting all the types to Python objects and whatever. We don't need any of to do any of this. We can just be users. So now inside, say our models, right? So this game class that has just like, you know, what is the number that you should be hitting? What is the current score you have? Which round of the game is it now? And so on and so on. We can start using Python. So before we had this nice function points that was written in Swift. We actually are like, you know, good programmers. So we even wrote tests for it. So we know that if we get like bullseye, we get 200 points. If we get like one off, like we're gonna have 149 because you get 100 extra points for hitting bullseye, 50 if you're within 5 points. And if you're like very far, you just get as many points as the distance from the perfect score. So we can run the test here with this nice button instead of line 23. It'll take a while, but build succeeded, and hopefully it's green. Yeah, okay, it's green for now. We're gonna fix this now. Because green is boring. Okay, so let's bring up the game again. So this is Swift points. We don't want Swift, we want Python. And the reason why I wanted to show you this is that the syntax of using Python inside Swift with PythonKit looks super nice. You actually have to import PythonKit first, so let's do it. Okay, we imported PythonKit. But now what we can do is we can say that we will have random, and random is a Python library that we're just importing. So we imported a Python library, and now inside Swift, we can literally say that we want to say return random rand int we never give 1,000 points in the Swift version, so let's say between 1,000 and 2,000, so we know that we're actually running Python. It will not be happy with us because what is it? Well, randint returns, which we can check with option click. It returns, no, it doesn't return anything. Oh, it returns essentially like a Python object, right? So we need to convert it to an int. In fact, like let's see that it's like result, so you'll see what type it is. Yeah, it's a Python object, right? So we need to convert it to an integer so that result, or like let's convert it right here. Int, yeah, and that's almost fine. Like if we put result here, it'll still yell at us because, you know, it's Python. What if you don't actually return an int? Well, then there's going to be nil. So you're going to have to say, well, for this particular purpose, we're not going to do try catch or whatever. We're just going to say, yeah, like it'll be int. If it's not int, then the app will crash. Okay, fine. But this is fine for now for like a short talk. Like you don't do it in actual applications on the App Store. Okay, so now let's see if this actually does anything. Build succeeded. Let me just press hit me, and it gives us like thousands of points. This is Python running inside a Swift UI app. I'm already happy with this. This is already cool. And now what we could do is we could keep writing Swift using Python libraries. This is not exactly what we want, right? Like we want to actually write like longer Python pieces of code. So even though this is cool, let's extend this and just actually create a file inside our resources. Oh, we're going to be calling, say, script PY. Annoyingly, just like recently, Xcode removed support for Python syntax highlighting because of the new parser. So we're going to be left with just like regular black colors here. But yeah, we can do the same thing here. So like we can say import random. We're going to have like def points that, you know, there's a guess of int. And, you know, we're going to be returning an int. And here, like, we can return what? This random int 1,000 to 2,000. It's the same thing, but in a Python module. So, okay, like, will this work? Like, you know, spoiler alert, it won't. You know, if you just replace this with script, and say script points guess, this should ideally work. But what will actually happen is something that we know from Python, which is an import error. Oh, we cannot find the file. Why? Well, because we never configured where our files are. So let's do that. If you get import errors, you should tell your Python kit where your modules live. Usually you don't have to do this when you're using Python kit inside like Mac applications, which is what Python kit was created for. But for here, you do need to be a little hacky. Like I hope to improve this in Python kit in the future, but for now, you really have to use some environment variables. We're going to be doing this, but just as you don't import things inside functions in Python, we don't really want to import things inside a function here, because what this will do is it will actually instantiate a new interpreter with every call, which is like super wasteful for your battery and everything. So instead, let's just say that we are going to have our script, which is a Python object. Everything is a Python object in Python. And here, we just want to instantiate this. No, there's no let anymore. And this indentation is making me crazy. Somebody should write an auto formatter for this. Yeah, cool. So what we want to do is to find a directory for Python resources. So the way you do it is just to say path is a bundle, which is what you actually have, like this bundle with your app and like all those other files. The main bundle, which is actually what ships. And we want to have a path to a resource, which is path for resource. And we want to have this Python/resources directory. It actually wants you to say, well, of which type? So what is the file extension? There is no file extension. Yeah, so if we have this, because like it can also be nil, it might not be found. So if it is actually found, then we want to set it inside the Python path variable. You remember Python path? It's like, you know, days of yore. So, you know, maybe there should be virtual, no virtual environments for this. Okay, so path, yes, and replace whatever you found. So like, yeah, always set it. Okay, this should disappear. All is good. Cool. So will this find our application now? It should. If it won't, I will be surprised. Okay. Boom, it found our file again. So now we can actually code here inside the script. You know, we can actually put more code. We can now like do more imports. We can do interesting things. But again, I set up all this phone thing to show you whether this works on a phone. And like, spoiler alert, this does not yet work on the phone. We're close, but no cigar yet. So if you actually stop this and want to run it on Lucky 13, you'll be unlucky for a while. You'll do exactly the same. Yeah, there's warnings, that's fine. It'll be running, so let me show you that it's not running. Current thread, no Python frame. It's like something is wrong. No module named encodings. This is terrible. Why? Oh, because it looks on my phone for this path. This path will never be found on my phone because this is my Dropbox directory on my laptop. Oh, okay. So what we need to do is we need to, and that's in the app, right? No, we were putting the script in the game. Yeah, so we need to also set Python home, which is the environment that actually says, what's your prefix? This ideally should be programmatically set, and not the way we're doing it right now. This is hacky, but it will work for now, and it will work with PythonKit so that this is smoother. For now, though, we can actually press play here, you know, and build succeeded, which is good enough. It actually started. Let me show you that there is an app on the phone right now, okay? And if I play around with it, I can actually hit it bad and still get thousands of points, and I can hit it, oh, maybe, well, almost, yeah. But see, like, you know, this is the thing, and there's like a leaderboard and whatever, like, you know. So we made it work. Now it works on the simulator and on the device. You can ship this. Apple will accept it in the App Store. It's good. I could go on now if I had more time, because, you know, now this is where the interesting stuff happens, where you can just start coding in Python. Like, it's awesome. But the talk was about the setup, which took me like weeks to actually go through, because there's multiple choices for each of the step, which library you want to do, like build Python 3.11 with, like, because this is 3.11, so you're one of the first people to see 3.11 working on a phone. But also, like, you know, the thing is, now you can do many, many wonderful things with apps. So some ideas for this would be, you know, you can make users script their apps, right? So they could like automate some workflows. They could customize their apps, right? They could do like app behavior changes, right? So you can actually plug it inside some Swift code. As you could see, like the Python functions that we had in our script now can be just called from Swift regularly with a little bit of help so that you convert Python objects into Swift native data types. Arguments from Swift to Python are already automatically converted, which is awesome. But the other way around, you actually have to be explicitly casting, right? So, you know, you can do changes to app behavior both by the user, but also by yourself. So you could make some stuff like, you know, some bundle of code that you have on your website or whatever, and just update it without re-uploading to App Store. Is this elegant? Maybe, does Apple love this? Probably not, but do people do it? Like, I don't know, Facebook? Like, yes, they do. Smart content templates. So, for example, if I create a new note, but I'm in gym, I could have like a gym score note, and it will automatically pre-populate with stuff that I should do today. Or like level definitions in games. Like this is in fact what like Civilization 4 used Python for. So, you know, you could actually just define levels using Python code, which is nicer than just using something that is static. Generative music sequencing, again, like, for music, just saying, I want this note to play after this note, wait this much, and then play another note. Like, plenty of ideas that you now enable users to do because you write an application in a first-class language, but you enable scriptability on the user end. So yeah, I could just go on, but I'm out of time, 2 minutes. So let me just say that what we just accomplished was we ran Python 3.11, which is in beta, that we built ourselves. I didn't actually build it right now because it takes like 15 minutes for like all those Xcode stuff, but like, we use the .8 files by make iOS from Python Apple support by Beware inside a Swift UI application on an actual phone, as you could see, with no Objective-C boilerplate needed. So it was all Swift. And this would not be possible without the help of Russell Keith McGee, who made Beware happen. So huge help from his end, like, I love the guy, thanks. Corey Benfield actually helped me convince the Swift compiler to statically link libpython.a. Without him, this would be a theoretical talk. This was a practical talk, thanks to Corey, who works at Apple now on Swift on the server side. Ray Wenderlich taught me iOS. Like, those are very good tutorials that, are kind of directed towards people who are new to programming, but also are not super annoying to people who already know some other programming language, so recommended. Pedro Jose Pereira Vieto wrote PythonKit, thanks to him. Ned Deely takes care of macOS and Python, including installers that, people are using when they are downloading macOS binaries from python.org. Lawrence Dana helps bootstrap Apple Silicon support that we just used back in Python, CPython 3.9. So he actually was an Apple employee at the time and contributed this to us. So thanks to him. And Ronald Ossoren wrote PyObjective-C, which is kind of the precursor, this granddaddy of connecting Macs and Python, and helped bootstrap Apple Silicon support by reviewing and making his own changes as well. So thanks for all of those. My name is Łukasz Langa. Thanks for coming. I hope you liked it.
Thanks very much, Lucas, for that great talk. We have 2 minutes time for questions. So let's see, do we have any questions from the audience?
There's a question.
Please step to the microphone.
Yeah. Hi, great talk. Just a quick question. Your dummy function, please link Python, is that still needed at this point when you've imported the other
It
stuff?
is still needed. Like, ideally, we will have like a more elegant way like of forcing linkage, for example, by PythonKit actually doing something. But like, you need to convince the Swift compiler that Python is needed. What PythonKit is doing, it is actually like just trying to find symbols inside your binary, but dynamically by DLSym. So within the code of your application, it doesn't look like you need python.h. So you need to really just force it somehow. Yeah.
Can we have the next question, please?
Thank you for the talk. I was wondering about if you can pip install things on iOS, and especially the binary package.
No, not in this way of embedding. Yes, in Python, but also no. So this is really a long question, so like very short answer. We could make pip work for pure Python dependencies so that they could install into some local storage and you could import them with some Python path angling. That would be possible. For stuff that has any binary packages, you need to either compile the dynamic libraries yourself because you need to sign them yourself. Otherwise, iOS won't enable you to, kind of load the dynamic library. You will have to do it yourself, or just actually include it in the static binary, as Python is doing. Python is also including everything inside a single binary because it's just kind of, it's more, I don't know, like it's a surer way that like the thing will work. Like, so yes, like iOS now allows you for dynamic libraries, but you need to sign them yourself. So wheels from PyPI, they cannot work because they're signed by somebody else, or as is the case now, they're not signed by anybody.
Thank you.
Thank you. And we can do another short question.
It's really impressive to see Python running on iOS. Do you know what the performance is like compared to running on, say, macOS laptop silicon?
Yeah, performance is better than on Intel Macs. It is weird, but like, M1 in particular, but also like those like A processors that are predecessors of M1 is very highly optimized for automatic reference counting, which is part of Swift. And it just so happens that Python also uses reference counting everywhere. So like for some reason, like Python is pretty quick there. Obviously, it is like an order of magnitude slower than Swift because it is using an interpreter loop to interpret your code in real time. That is kind of the point because we are providing this code on the user level, right? Like we could make like an edit box and the code could be literally provided by the user. But it's still faster than Intel Max. Like, you know, it's pretty impressive.
Thank you.
So thank you very much. That's all the time we have now. Please give another round of applause to Lukasz. And we will be back in 5 minutes. Thank you.
Testing, 1, 2, 3. Can you hear me?
Okay, welcome back. As you all know, the EuroPython this year is a combined live and remote event, and I'm really happy to remotely introduce the next speaker all the way from Australia. We have Kalab Hathing. He's been a Pythonista for 20 years and is a principal software engineer at Capiche, and he wants to talk about why Python is slow. So please, let's have a welcome round of applause for Kalab.
Hi, hello to EuroPython, and thank you for attending my talk. I think the organizers have done an amazing job on this. I was just watching Luciano in the other session before this, talking about typing, and I really felt like I could, at least in a small way, be part of the conference. So thank you again to the organizers. I have quite a few slides to get through, so I'm going to be speaking fairly quickly, and I don't think I'll have a lot of time for questions at the end. But if you have any questions, please email me or contact me on Twitter. The topic of my talk is why is it slow? We see many talks over the years focusing on how to improve performance in software, but we don't see very many talks about how to go about analyzing performance problems or figuring out why is it slow. A little bit about me, as you heard in the introduction, I'm an engineer at Capiche. Capiche is a natural language processing company, and we're trying to solve the problem of how to analyze customer feedback at scale. I've made a Learning Python video course a couple of years ago in 2016, which is still pretty relevant today. Very few people know that it exists because it's only really available on the Safari platform at O'Reilly. And recently I also wrote a book on async I/O. The goal of this talk, what I really want to do is to try to give you a little bit of my experience over the years trying to solve performance problems. I really want to try and give you a strategy for how to approach the problem. I want to give you a little bit of structure for how to think about how to approach this problem in different scenarios. But I'm not going to be talking at all about how to actually make things faster or any kind of low-level diagnosis, hardware issues, CPU registers and cache, and so on. So the scope of my talk is I've broken it up into 4 sections. The first section is going to be on fundamentals, what you really need to be thinking about when tackling a new performance issue. In section 2, we'll talk about what you can do when it is easy to run the code, when you can run the code over and over again in your dev environment, and you really have a great deal of freedom in how you tackle analyzing the problem. In section 3, we'll talk about when it's not quite so easy to run the code, and some strategies you can use there. And in section 4, we'll talk about distributed systems and microservices and how your thinking needs to change to approach that kind of scenario. So let's jump right in. Okay, section 1, fundamentals. There's really only one fundamental that I want to drive home in this talk today. The most important thing that you need to obtain when analyzing a performance issue is when the system is being slow, what is it trying to do? Not in a fine-grained detailed way, but in an overall way. You really want to understand what the whole program is trying to do while you're having this performance problem. And I really want to emphasize that very importantly. It is super easy when analyzing performance to try to focus on one particular function or one particular line and try to optimize just that thing. But by doing so, you miss out on a whole bunch of enormous performance opportunities where by changing slightly the design of the program, you can get massive boost in performance. So I'm going to emphasize that again. You want to figure out what is the code trying to do while it is being slow. Yeah, and you have to look beyond the current line of the current function. This knowledge gives you the biggest leverage to be able to make a huge impact. You'll often discover in practice that when you find the cause of a performance issue, that code can very often be producing the same result over and over. Like, for example, it might be an initialization. In the modern age with all these machine learning models, sometimes we find that model initialization happens over and over again at the startup of a program. And sometimes you are able to save that result and cache it and just reuse it again on subsequent startups. But the best outcome, and this happens disturbingly often, is that sometimes when analyzing a performance problem, you find that a slow path in the code is not even required. It may be there because of legacy reasons. It may be that previous people in the team worked on the code several years ago and they're no longer in the team, and no one really quite knows what the code does. But when you discover such an opportunity, you can get a huge performance boost simply by deleting that code. The best optimization you can do is not to run a certain line at all, and this by far beats any kind of algorithmic improvement. If you only focus on micro-optimizations, it's easy to miss the really big wins. So long story short, really the concrete thing that you want to obtain when analyzing a performance issue is you want to get the call stack. This is key. While the program is being slow, you want to see the line that it's currently busy with, or the function it's currently busy with, as well as the entire call stack all the way from how you got to that line in the flow of the program. You want to know what initiated the slow code and why, because this gives you the leverage to be able to make strategic design changes. So before we get into more concrete details, I want to talk a little bit about tools. If you search for Python performance tools, you will find many, many results, and these stretch all the way back the past 15, 20 years. There are many tools in this space, but for me personally, my focus in this talk is to give you a short list of the things I personally use at work and in my personal projects. And my criteria for what I choose to use really tries to maximize the product of simplicity and impact. It has to be easy to use, and it has to be easy to get results quickly, because it's really easy to get bogged down in very complex tooling where you don't really get a lot of bang for buck by using some of those sophisticated tools. And the final tip I'll give you in this section is instead of choosing the latest and greatest tool and then finding out what you can do with it, it is much better for you to first decide on the kind of data you want the tool to give you, and only then select the tool that can give you that data. So I've already told you that what I'm really interested in is the call stack. So I tend to focus on tools that can give me that. So here's our first concrete section. When the code is easy to run and you have all of your tools available at your disposal, you can run it on your dev machine, and you can throw many strategies at the problem. What is my go-to for how to approach that scenario? Local code is easy to run. You can run the program as often as you like. Sometimes you do have to rearrange things. But having tests makes it really easy to run different parts of your program independently. So that's really key. Tests are not only about trying to prevent regressions, but they also help in performance analyses, because the discretization that tests provide can also be used for performance analysis. For example, if you're using the PyTest test runner, you can use the -k parameter to specify a particular keyword that will narrow the scope of the tests that you run. And I have frequently created tests specifically to analyze a performance issue, not even intending to commit those tests as part of the version control system, but only so that I can invoke it using PyTest and PyTest plugins, which we're going to get to in a couple of slides. So my first big trick is something that you may not have come across before, but the idea is that you can just use Control-C as a performance analysis tool. This is by far the best bang for buck that you're going to get. The idea really is you run your program, and while it's being slow, you simply hit Control-C. What you are immediately presented with is a stack trace. And the stack trace tells you what your program was doing while it was being slow. In particular, if you have a big skew in the code that is fast and the code that is slow, when you get the stack trace after hitting Control-C, you almost always see the same trace, because that body of code is consuming most of the time. Mike Dunleavy has quite a detailed Stack Overflow post about this, and he calls it stack sampling. If you're in a hurry and you can manually interrupt your program under a debugger, there's a simple way to find performance problems. You just halt it several times and you look at the stack trace. If there's some code that is wasting some percentage of the time, say 50% or whatever, that is the probability that you're going to see that stack trace that gets shown after you halt the program. This seems like it's too simple to actually work, but in fact, it works surprisingly well, and in exchange for very little cost to you up front. I'll run through a quick example, and I'm going to be moving pretty quickly here because I did a run through earlier today of my talk, and I ran out of time, so I don't want to spend too much time on this. I'm really going to try and just hit the high notes on the concept. Here I have a fake program that does a few silly calculations. There are three functions, f1, f2, and f3. And in the main function, we simply call those three. What we're going to do is we're going to run this program, and we're going to find that it takes about 2 seconds to run, which is a little longer than we think it should based on the complexity of the code. We're going to try to use our approach of hitting Control-C during the 2 seconds, and then we're going to see what happens. So what in fact happens is we do get a stack trace, and this is the stack trace that we get. And what you can see here is that we can follow the stack trace all the way down from the main function, which is the top of the stack, to where the function is being slow, so all the way to the bottom here in F1. And in fact, this function really does take most of the time. It's a Fibonacci number calculation, which is very recursive in nature. And the interesting thing about this approach is that regardless of when you actually hit Control-C during those 2 seconds, you get the same stack trace every single time. It doesn't even matter what the call order is. In our main function, if you call F1, F2, F3, or in reverse order, F3, F2, and F1, you still get the same stack trace back. And the reason for that is that F1 consumes all of the runtime in this city program. And this technique works surprisingly well in a large variety of these ad hoc situations where, for example, you have a PyTest invocation that seems to take longer than it should. You can use this technique, hit Control-C, and you will often find that you may have a fixture, for example, that is doing a lot of expensive initialization early on. So this is a really cheap way of discovering a performance bottleneck. Compared to cProfile, for example, I want to highlight the cost of not having a stack trace. The same program run under cProfile produces this output. It is true, it does highlight the fact that it is our F1 Fibonacci calculation that is taking all the time. And it also highlights that it has a large number of calls. But what we don't have in this output is we don't have the relationship between F1 and main. These calls will just appear in whatever order they sort according to the total time and the per call time and so on. So we lose that link. So it's easy to see the time spent or the number of calls spent, but not why that call was being made. The other thing to keep in mind is that cProfile is quite expensive to run. For this particular dummy program that I'm using here, the original runtime was 2 seconds, but when you run it under cProfile, it was 74 seconds. In larger, more complex systems, that impact can really burden you when you're trying to figure out the performance behavior of the system. So just to summarize, cProfile is pretty expensive. It measures everything, even things you're not really interested in. And the worst thing is that that table that we just saw, when you see the numbers presented in that way, it feeds the temptation to want to focus on a micro-optimization because you see that a particular function is being slow and that breeds the temptation to want to make that function run faster, rather than thinking about the design of your entire software stack. However, cProfile redeems itself because it does actually collect the information we need. It just doesn't automatically expose it in its default output. So another neat trick, and the second and final one in this section, is PyTest profiling, which is a PyTest plugin. So the key thing is, after you install PyTest profiling, this command line parameter, -profile SVG, is really the magic. It's very easy to configure if you have a PyTest suite and call that. And when you do that, what you'll see printed in the console output is this SVG file that's been created. That SVG file looks something like this. It gives you a large map of nearly all the functions that got run during the execution of your tests. And it has a color coding for the cost. So the warmer the color, the more costly that function call is. And the colder the color, the less costly. And I'm going to zoom in on a diagram like this very quickly. It also gives you some of the stats that you get usually in cProfile output. Like, for example, it gives you the total time and the own time that was spent just in that function. But it also gives you the call stack because these arrows show the relationships between all the function calls. So you can use those two pieces of information to gather quite deep insights about the performance behavior of your system. However, bear in mind, this is a lot more expensive than Control-C because it uses cProfile and cProfile is slow. Okay, we're about halfway through. I think I'm doing quite well for time. So the previous section was when it's easy to run the code locally. In this section, it's more complicated. Some reasons might be that the code that you're trying to analyze makes a lot of use of threads and sub-processes. It might be difficult to run a narrow part of the program, or you may not know which part to run. You may find in a particular scenario cProfile is too expensive to run. You're just not getting feedback fast enough after making changes. And finally, you may have significant code in native extensions, and cProfile doesn't highlight any information inside those. So my go-to in these scenarios, when the simple tricks no longer work, is a really magical tool called PySpy. It really is impressive. I have here with these green check marks, basically, a wish list of all the features that I've wanted in the past before I found PySpy about things that it can do. It's a sampling profiler. It can attach to a running Python process. So, for example, you could use it in a production environment. If a process seems to be hung or in a frozen state, you can attach it and get feedback. It has a very low speed impact. It can analyze sub-processes. It can dump call stacks on command, which we'll get to shortly. And it can also include stack trace information from native extensions interleaved inside the same Python extensions you would be used to seeing. So let's have a bit of a look at PySpy. It has 3 subcommands. The 3 subcommands are record, top, and dump. And we'll just take a quick look at each of those. So the way to invoke it on the command line is it has a CLI called PySpy, and then the subcommand, which would simply be record. And in this case, you can see, just like we saw previously, it's going to dump an SVG file. And you can also add the -- subprocesses command, which will also measure subprocesses. So what that produces is a flame graph that looks roughly like this. I'm not going to go through this in detail, but I just want to give you a sense of what you can obtain with this tool. In practice, you can hover over each of these worms and you get additional information and metrics. And you get that information about which function calls are being made from which other function calls and their duration based on the width of each of these bars. Okay, moving on. So PySpy top. It gives you a view very similar to the Unix top command, but instead of seeing processes, what you actually see is functions and file names in your running Python program. As they consume more or less time, they'll change their order inside these columns. And on its own, this isn't that convenient because you're not really seeing a stack trace, you're just seeing a measurement. But it is super convenient to be able to just attach this to a running process in certain situations, and then getting a very quick sense of which line the current program is stuck on. And this final command, dump, this is the one that is really useful. So again, you have a subcommand called dump, and you attach it by PID to a particular running Python process. And then what comes out is a list of all the threads with the call stacks from all the threads in that running Python process. And as I said, you can produce it on demand. So you can execute your program, or you can have a program running in a production environment, and you can attach this with the dump command and then get an immediate snapshot of what all of the threads are busy with. This is super amazing for being able to jump in and get performance metrics really quickly without very little ceremony. And finally, I just wanted to highlight some other features that the PySpy dump command has. It can show local variables and include them within each frame in those call stacks that I showed in the previous diagram. And you can add the -- native parameter to include call stacks from native extensions. Those do need to be compiled with an additional flag, and that is documented inside the PySpy documentation. But that is how you can have your call stack from Python and from your native extensions interleaved together in that live dump view. Okay, and finally we're on to the final section, and this is the most difficult one. In fact, it turns out this is the easiest one after all, because you don't have very many options to get good information. There's really only one path to go down. Just to clarify what I mean by a distributed system, you have a bunch of services running perhaps on a bunch of computers that are making network calls between themselves. And the lifetime of each of these services running on the different computers is all different, and they deploy differently and so on. But they do work together to provide some overall service. They are much more difficult for you to be able to run code at will, unless you have a very small system. Services depend on other services, and those can also depend on other services. So it's even difficult just to reason about the system architecture, usually. And setting up a full dev environment for such a thing can be hard or even impossible. And worst of all, the performance behavior can be non-deterministic, where the slow behavior can only happen sometimes. Like maybe when only one user does something, or maybe when only one kind of file is being processed by your software, and something like that. Nevertheless, the same rule applies, the golden rule. The fundamental thing that we wanted, even in the simpler cases, was that we wanted a call stack because we wanted to reason about what the entire system was doing when we were observing slow behavior. In this case, though, what we really want is a call stack that operates across distributed network services, right? We want to know which service called which other service and how long each of those calls took. And we would ideally like to see that in an ordered relationship, like a tree. Distributed tracing provides that call stack, and it gives you timings for each of those pieces. I have a definition here, which I've stolen from Honeycomb. It's a technique used to monitor and observe requests as they flow through distributed services. Distributed tracing provides visibility into each request and all of its subsequent parts. There is an industry standard that has been built up around these ideas called OpenTelemetry, and I have the link here. There are many vendors that provide tools that do this, but at Capiche, we're using Honeycomb, and I'm going to use Honeycomb in a couple of examples. So the key thing that you get from a distributed tracing tool is a view like this. You get a tree on the left. So right at the top here, our trace begins from a Django endpoint, which is the entry point into our system from a front end, like a React or a Vue front end application. And from this point on, that Django system service is going to call other services in order to accomplish some goal. So I've highlighted here in red, we can see that the service name changes throughout the call stack. And in this example that I'm showing here, we have 3 services, but it can be more, it can be less. And these time-based bars that run across tell you how long that particular step was consuming. And you can see these layered in a nested fashion. There is a cost, though, for all of that power. The cost is that this data needs to be collected continuously. You can't just turn it on in an ad hoc way, as we saw with other tools. You have to add instrumentation to your software, and all of these trace events have to be transmitted to, in my case, the Honeycomb servers, so that they can be rendered on demand. To set up such things is fairly straightforward. You typically would initialize the system by providing an API key, which you would get from the service. For things like Django and Flask and other similar frameworks, Fast API, there is a middleware that can automatically be configured to integrate into at least the REST API part of the stack. And then inside your code, you have to add additional things like this. For the case of Honeycomb, they have this Beeline client library, which gives you 2 main tools to work with. The one is a decorator that you can attach to functions, and the other one is a context manager that you can use to scope discrete blocks of code. And those 2 things work together to send these trace events to Honeycomb. I have a quick example of a case study here that we really did use at Capiche, where customers upload spreadsheets which contain customer feedback data, and then we process and analyze those. And this screenshot is in fact taken from a real issue on one of our issues in the issue tracker, where we were trying to process a CSV file and it was incredibly slow. And this might be too small to read, but this first big bar at the top is about encoding detection. Literally just trying to detect the text encoding of the uploaded file. And the second one is to generate a CSV schema from the uploaded file. And we found that we had a really problematic code path that was producing very slow results. And from when this issue was reported to the resolution of the issue was within 1 workday, because we had these traces available. And I could immediately jump to the trace in Honeycomb and immediately see that we had not 1, but 2 separate problems. And we were able to fix both of those and resolve it really, really quickly. Distributed tracing is extremely powerful. And I have a confession to make. I use this tool even during software development, just when I'm writing a new feature or I'm working on a bug, because all the code is already there. The instrumentation is already in my software. So as I'm writing new code, I just configure an environment on Honeycomb for myself, for personal use, and then I send events to that, and I can analyze the performance even during my development process using those really nice graphics. In particular in Dev, I trace all of the SQL queries, especially for Django and for the Django ORM, because it's really easy to emit way too many SQL queries if you're not careful about how you control the execution of those queries with nested models and so on. Okay, so in summary, remember my advice is what you really want to get when trying to figure out and analyze a performance problem, and you're coming to that problem from a blank slate, what you're really trying to get is a call stack, because you want to see what is causing the program to be slow through the entire stack right from the start of the program. When possible, do give Control-C a try. If you have something that is running slow on your machine and you want to figure out what is making it be slow, hit that Control-C and you can get an immediate stack trace and try to make sense of what's happening. If you need a bit more detail than that, if that's producing confusing results or you have multiple issues that you're trying to figure out, PyTest profiling is a much more comprehensive approach, which will give you that large tree of SVG that you can use to check the performance of many functions at the same time. If you have special needs where you can't run the code at will, PySpy is a really great tool to be able to attach to a running Python process, and it makes very, very little performance impact on that running process, but can give you real-time information, including cumulative stats through the top command, and the dump command can also give you call stacks from all of the subthreads in real time. And finally, if you have a distributed performance issue where it's quite difficult to isolate the code to a single system, you will have to use a tracing system like Honeycomb to be able to analyze performance, and that will require upfront instrumentation of your code in order to emit those events. I know that I have left out a huge number of tools, and I'm sure other people would have their own suggestions for what will work well for them. But this is the set that I currently use. So these are my go-to options for the different scenarios that I've highlighted. And that is the end of my talk. Thank you everyone for attending.
Thank you very much, Caleb, for sharing your tools and all these inspiring tips for us. We have a short amount of time, and since this is a remote event, let's check if we have a remote question. I see something, no? Okay, then we also can have local questions if somebody in the audience has one. If you do, we have a microphone over there where you could go and ask one. And let's see if I see a question. I do not. I see somebody running to the microphone. Please go there quickly. Thank you.
Hey, thank you for this work.
Yeah, a bit closer.
Closer? Yeah. Right. So thank you for your work, for your talk. So my question is with regards to these tracing systems. You mentioned Honeycomb. Are there any other alternatives that you know of that we can check out?
Many. There are many. If you just Google distributed tracing, you'll find many of them. There are also open source systems that you can self-host. But off the top of my head, JagerMonkey is one. Datadog provides a system. I think Sentry now also provides distributed tracing. I say that perhaps under correction. But there are many. And new ones are coming out all the time. So probably what's better for you to search is not distributed tracing, but OpenTelemetry. That's really the key thing, because many vendors have joined forces to decide on a common interoperation protocol for distributed tracing. So that's the thing to look up, is OpenTelemetry.
All right, thanks.
So thanks for your question, and that's about all the time we have. So let's have another round of applause for Caleb. And let's hope that we see you at another EuroPython in person. So thank you again.
I wish I could have been there.
Okay, yeah. So we'll take a 5-minute break and then continue with the next talk. Okay, thanks everybody for coming back to the last talk of this block. We have with us today Leonardo Giordani, who's the author of the book Clean Architecture in Python, and he has a talk with the same title. Please enjoy.
Thank you, Martin. Thank you for being here. So the title of my talk today is Clean Architectures in Python, a tale of durability, utility, and beauty. And my goal today is, so I'm here because I want to share my views on system design, give you an example of what I discovered and what I learned, and maybe meet people who are interested in system design as well. So this is me. Well, not a picture of me, but you know, I'm a developer and a blogger. You are welcome to visit my blog. I usually write about Python, obviously, TDD, object-oriented, cryptography, and infrastructure. These are the main things I like to write about. So today it's a talk about the clean architecture, and I want to start with a question, thinking a bit about what architecture is. We mention architecture many times, the architecture of a system. What is it? What is its definition? So I found this in a book that has been around for a while, De Architectura. It means about architecture. It's been written a couple of thousand years ago. Vitruvius, who was a Roman architect and engineer, says that architecture is about firmitas, utilitas, and venustas, which translated in modern English is durability, utility, and beauty. So Vitruvius says that architecture is about things that are durable, something that has to last, has to be useful, has to be beautiful. And for me, this was very interesting because how many times do you think about your code as something that has to be useful, beautiful, and durable? Useful, yes. Nobody wants to write something that is useless. But what about durable? We change framework every 2 years now, right? Or every 6 months, I don't know. So having something that lasts. And beautiful, that's the thing I'm mostly concerned about. It's interesting, let me mention this, that Vitruvius was an engineer and an architect. And these two professions don't go together that much nowadays. It's interesting to think that engineer, the word, comes from engine, but engine comes, when we discuss about engines, we think about something mechanical. But engine actually comes from ingenuity in Latin. It's from cleverness. So it's less about mechanical things, it's more about solving a problem in a clever way. Anyway, I went on and I checked also on the dictionary, modern English dictionary, and I found these two interesting definitions of architecture. One is the art and science of designing and making buildings. And the second one is more concerned with computers, and it says the internal organization of computers' components, with particularly the reference to the way in which data is transmitted. I like these two definitions. I wanted to come up with something a bit more compact, so I tried to merge them into this, which is the art and science in which the components of a computer system are organized and integrated. I want to stress art and science. How many times do you think about what you do daily as art and science? As science, yes, data science, computer science, the mechanical part, right? What about art? When do you look at your code and think this is art? Why is it not data art? Why is it not computer art? Not as in, you know, painting something with the computer, but our code is beautiful, or it can be. And the other two interesting words here are organized and integrated, because a system architecture, when it comes to computer science, is all about where components of the system are, and how data flows between them. So this is the integration part. Cool, now that I defined architecture, the following question is, do we need it? So do we need things, our code, to be useful, durable, and beautiful? And this is up to you. I'm positive about this, otherwise I wouldn't be here. But I want to give you a couple of examples. And one comes from the traditional architecture, and it's the bridge that is in front of this building, the Samuel Beckett Bridge. It's interesting, I was looking at it these days, and I thought, does this bridge have to be shaped like an harp? If the requirement of the bridge is just to take cars from one side to the other, it doesn't have. You just need a plain bridge, right? Something that I could design because I don't know anything about bridge design. But if the requirement is to make your journey better, well, being shaped like a harp in Dublin is a nice thing to have. So this is food for thought, maybe, you know, like what is the requirement of your code? What is it that you are creating? When you create a library, do you just create some machinery, or do you create something to make the journey better? The other example I have, it's about something lasting a long time. The Unix system, so an operating system, was designed in '71, so 50 years ago. And it was well thought. Not everything in a Unix system is perfect, okay? Sometimes it's far from it. But it was well thought. So well designed that I am running a Linux machine, and Linux is a clone of Unix. And many of you use Mac OS, which is a derivative of Unix. 50 years. So again, how many times do you look at your code, the code that you write, and you think, in 50 years, people are will still use this code, or at least these ideas. Anyway, I'm not the only one who thinks that system design is an interesting thing. There are much smarter people than me who wrote a lot of books. There are vast literature about this. I selected 5 books that I read, which I believe are interesting about the topic. Some of these are door stoppers, pretty thick, okay? So if you are not up for the challenge, I recommend retrieving at least the 2 in orange, so design patterns and enterprise integration patterns. At least read the introduction. And I'm not joking, the introduction to these 2 books, the 2 introductions, are short, but they give you a narrative of the challenges and some of the solutions that you might have when you design a system. And I was really you know, flabbergasted when I read the introduction to design patterns, because it was like, hey, I face these issues every day. I want to mention another thing about enterprise integration patterns. This is a book about messaging, message-based systems, more about distributed systems, if you want. But it's interesting that message-based systems, microservices, for example, software design and languages, they are all in the same league. They share a common trait, which is messages. Object-oriented programming, and you can quote me on this, is supposed to be about objects that exchange messages. So every time you call a method on an object, you are sending a message to something. So it is a distributed system. And if you think about that, when you code in Python, if you think about messages, this might not change the code itself because you are still calling methods. But it will definitely change the way you think about your code. It's a bunch of objects. It's a distributed system, and I'm exchanging messages. Anyway, this might be for another talk, another time. Now that I defined architecture, and I decided for you that we need it, let me define clean, because this is about the clean architecture. I found it easy to define the opposite of clean, the picture in the background. If you look at that system, you can definitely say this is not clean. It's not tidy. Good luck maintaining something like that, okay? They said, pull the green cable. Yeah, good luck, okay. This is an extreme example, probably, but sometimes our code looks like that, right? You change something and suddenly everything crashes, nothing works anymore. Instead, in a clean system, or in a tidy system, if you want, you have these characteristic. For each component, you know the 3 W's, right? You know where it is. It's easy to find the component in the system. It's isolated. You know what it is, from the name, for example, and you know why it is in the system. You can say why it's been included. In the pictures in the background, there are two just, hardware systems, and they are tidy. It's easy to trace where a cable goes. Some are color-coded, so it's easy to understand, why they are there, what they are doing. Okay, now that I defined the clean architecture in terms of the words, let's go for the concept for an example. So what is the clean architecture? It is a concept that was introduced by Robert Martin some years ago. Robert Martin is a system designer, a developer. And I'm not here to advertise Robert Martin's work, mostly because Robert Martin is very good at advertising himself, but I'm going to use the same name. It's important for me to stress that the concept that Robert Martin dubbed the clean architecture predate his work. So they have been around for a long while. So let's call it the clean architecture, but it's a set of concepts that predate what Robert Martin did. What is it? It's a layered approach. So it's a way to structure your software project, right? Your code. It's layered and it's circular. So in the traditional, definition, we have 4 layers. You can have more of them, but these are the traditional ones. Entities, use cases, gateways, and external systems. What happens is that when you create something in a clean architecture, this component, will belong to one of these layers. And there are rules. There is actually one simple rule, well, one rule at least, which is that your component can see, I'm going to define what C is, can see only what has been defined in an inner layer. So if you create something in the use cases layer or ring, you can see everything that has been defined in the same layer, use cases, and everything that has been defined in entities. You are not allowed to access anything that has been defined outside. And that has to do with dependencies. The problem of unclean systems, remember the cables before, is dependencies between components. When you have a component that depends on other components, and these other components depend on other components, and you can't trace these dependencies, and sometimes they are circular dependencies. In a clean architecture, there are no circular dependencies. The golden rule, I'm going to introduce it now and then show you an example that clarifies it, is that you talk inward with simple structures, outwards through interfaces. What does it mean? Simple structures are data types that have been defined inside. So, for example, again, something in use cases can use data types, and I mean data types in Python, for example. You can instantiate them if they have been defined in use cases and if they have been defined in entities. If something has been defined in external systems, you don't see it. You can't instantiate it. Interfaces. Interfaces have to do, so they are related to dependency injection, which is something I will introduce later. What is an interface? Going back to what I said about objects and sending messages, when you send a message to something, you expect it to be able to receive that message. When you call a method on an object, you expect that object to, well, have that method, right? Otherwise, you get an exception. In Python, we don't have an explicit way to state interfaces, okay, to create them. Even though we have now protocols, we have abstract-based classes, there are many ways to work with interfaces, and we can discuss about this another time because there is not enough time today. Anyway, I'm coming back to this slide later after the example. So the example today is simple. The code I will show is Python. It's valid Python, but I stripped all the error checking, a lot of things that are not useful for now. Obviously, the real code is a bit more complicated. My use case is to retrieve a list of items. It's very simple. When do we want to retrieve a list of items? Don't know. You have a social network and you want to retrieve a list of posts, right? Or you are Amazon, you want to show a list of proper items that you are selling. In this example, my use case is just a simple function. It exists in the use cases layer. And for the time being, it doesn't do anything. Then I define some entities. Entities are models. Okay, they represent real items that are in my business logic. So in this case, for example, something with a code and a price. Okay, just a simple class that captures data, encapsulates data. The entities live in the entities layer, and they are known to all other components. It's 2022, so we probably want to build a web application, but this is not required, okay? It's just an example. The web application requires a web framework because I don't want to implement, the logic to deal with HTTP requests and all these things. There are smarter people who did it for me. In this case, I'm using Flask, but I can use any other web framework. The web framework exists in the external systems. And I want to say a couple of things about this. I mentioned business logic before. The business logic is what you market. It's the core of your application. The web framework is not, generally speaking, part of your business logic. You are not marketing Django. You are not marketing Flask. You are marketing a social network. You are marketing items, delivery, whatever, right? So it's reasonable for the web framework to be in a very external layer where we use it, but we don't manipulate it. The core, the most important thing in a clean architecture, I would say in any architecture, is the business logic. This is what 99% of your time should go. Every time you spend configuring external systems, it's not wasted, but it's not given to the core of your business. Anyway, this is the web application, the web framework. Now, what is the task of the web framework? The web framework is there because it has to translate HTTP requests into calls. This is all a web framework has to do. Granted, it's not an easy task, okay? There are many things involved. But this is what the web framework should do. Get an HTTP request and transform it into a call, for example, for a Python function. In this case, this is exactly what I'm doing. I'm calling the use case, which is a function. Here, you see that the web framework communicates with the use case with simple structures. What does it mean? In this case, I'm using request args for the sake of simplicity. It's just a dictionary. And it's a simple structure because it has been defined in the language, right? So it might be an entity or it might be something that the language defines. All these things exist in Python. So whatever is defined in Python as a core language is available. So I'm sending to the use case a simple structure, something that the use case can understand. For example, I shouldn't send anything that is defined in the web framework, some structure that has been defined there, a type that Flask uses to manage an HTTP request, because the use case doesn't do anything, doesn't know anything about HTTP requests, and it shouldn't know anything. Okay, then we have to retrieve items and data. Data is stored usually in a repository. And we are used to think about a repository as a database, which is what I have in the example here. But I want to stress that a repository is much more than a database. For starters, it doesn't have to be a relational database. It might be NoSQL, MongoDB, for example. Or it might be something different, for example, a web API. It's a source of data, right? You call the API, you get data. It's exactly what you do with a database. It might be a bunch of text files, which is a rudimentary database. It might be a hardware sensor. That is a source of data. It's a repository, okay? So let's think about it as a database. I'm going to say database probably a lot of times, but the repository is the right word here. And the database, the repository, exists in the external systems layer. Because again, it's something that is not part of my core business. It's not my business logic. In system design, we usually call the web framework, the database, everything that is outside as a detail. We call it a detail. And many times it surprises people because they are like, what detail? I mean, configuring Postgres, you know, and all these things, it's complicated. It's not secondary. It's not just so simple. A detail means that it's not part of the business logic. This is not what I'm marketing. If my product works with Postgres or works with MongoDB, you are not concerned. You as a client are not concerned. Your problem is to receive a service. So this is why it is a detail. While the specific algorithm I use for my recommendation system, for example, is the core business, is what you like of my product. Okay, so this is the difference between a core business logic and a detail. So the database is a detail, even though it might be complicated. However, it exists in the external systems. So, as I said before, the use case is not allowed to communicate directly with the database. In Python terms, the use case is not allowed to instantiate anything that is tightly coupled with the database, that is connected with the database directly. Because if I hard code in my use case something which is, I don't know, Postgres, a library to interact with Postgres or to interact with MongoDB, I am coupling my use case with the implementation of the database. And this is not good because at that point I have my core business logic coupled with a detail, which might change. Might not be the same thing in time. So I create an interface. This is, in this case, we are talking about Python. It's an object that provides a facade. Okay, so a set of methods that are common to databases. So the web framework instantiates the database interface or the repository interface. The web framework can do it because it's in an outer layer. So the web framework can see what's in the gateways and passes so it sends the instance of the Postgres repo in this case to the use case. This is called dependency injection, if you're not familiar with the concept. I have a slide for that later. But look at it. The use case, the code of my use case doesn't have Postgres repo hard-coded in it. I'm receiving an object that provides methods. That might be an object of Postgres repo, MongoDB repo, type, whatever. The important thing is the interface or the set of methods that that thing provides. Cool, now internally, I'm in the use case now. And I have, finally, my business logic. Okay, this is where my brain comes into play, right? I have to write something that implements the recommendation system, the whatever filtering you want. Eventually, sooner or later, I have to use the database interface to retrieve the data. So in this case, I'm calling repo list, okay? Passing the parameters that I received from the HTTP request, or from outside, I should say, right? Where they come from is not important. The business logic might be, for example, to prepare the parameters, to add some filtering, you know, or to do something else. Anyway, back to the database interface. I'm calling repo list, okay, here, repo list. So I'm in the database interface now. And the database interface is tightly coupled with the database. That is Postgres repo. So it has been designed to work with Postgres, okay, it's in the name. So the two communicate with a specific language. In this case, I'm using SQL Alchemy. It's an object relational mapper, but eventually I'm in a mindset of querying a relational database. This is what I'm doing here, okay? I'm committed to relational databases at this point, and this is what I'm doing. So the two things are tightly coupled. What the database interface does is to, as I said, query the database, and then it transforms the output of the database. The database just sends me values, right? It's SQL, so just standard types known to SQL databases. The database interface has the task to convert those values into entities. Because at this point, everybody can see entities as a layer. It's a very inner layer. So the database interface can say, okay, these SQL values that I get become items, as in items that I defined. And these items are sent back to the use case as a result of the repo list. At this point, I can add more business logic, okay, just to say that obviously if you want to, if you have to call your repository, you can do it at any time. And your business logic is around that call. It's where you augment these results, okay, with your algorithms, with your cleverness, your product. At this point, the use case has the results, and it can send it back to the web framework or to whatever called it. And the web framework, so this is again, sorry, entities. The web framework knows about entities. So this can still be an entity, a model that I created. The web framework, again, has one task, that of converting the entities, which are specific models of my business, into something that is understandable outside. For example, JSON. Okay, this is the task of the web framework. My use case doesn't know anything about JSON, doesn't care, because the use case is okay with entities. It's part of my business. This is the journey of the data in a clean system, at least in this example, in a clean architecture. I want to go back quickly to the initial slide about the golden rule, right? Talk inwards through simple structures and outwards through interfaces. Have a look at this code. These are two different possible implementations of a use case. The second one is the one I used. The first one is the incorrect one, if you want. Why is it incorrect? It works. Okay, first of all, so it's not incorrect from that point of view. But this couples my code, the code of my use case, with the Postgres repo. It means that I can't use anything else. Or if I want to use something else, I have to touch the use case. But the use case is your business logic. And it shouldn't be touched because you change something which is a detail, where you store data. Okay? The second one instead, and this is a good example, I hope, of dependency injection, is when you create something outside and then you pass an instance of it. The instance has been instantiated outside, so the part of the code that is coupled with the type the Postgres repo it's outside. In this case, is the web framework. Your use case just receives an instance, something that can accept a certain set of messages. Does it make sense? I hope so. This is what happens in a clean architecture. Simple structures inside, interfaces outside. Cool. I want to tell you about the advantages of the clean architecture. Why should I go through all this pain? And there are two specific things I want to mention. The first one, probably the most important one for me, is testability. A clean architecture, a software designed with a clean architecture, can be tested very well. What do I mean by that? Look at the use case. I can easily isolate the use case from the web framework and from the database interface. It's just an object that receives a repo and some parameters and returns some results. So what I can do is to pass a dictionary, of parameters, a mock database interface, so something that pretends to be the database interface, but is not connected with any database. It's just, a mock. It returns a fixed set of data. And check that my business logic works, given that input gives some output. This allows me to test my business logic in isolation. I don't need the database to test my business logic. I don't need the web framework, because these are details. My business logic is not about details. At the same time, I can test the details because, details, but they are part of the implementation. So I have to test that my web framework works, and the web framework can be detached from the use case. Because the web framework, the only task, is not a simple task again, but the only task of the web framework is to accept HTTP requests, convert them into calls, get the result of this call, and convert it back to an HTTP response. As I said, it's not simple. I have to test that this works, and I can do it in isolation. And last, I can test my repository interface. This requires the database, because this is an integration test, okay? I'm testing that the facade of the database works, so I need the database running. This might be a slow test, that you might run just sometimes. Again, I want to stress this. I see it too many times when it comes to testing, in particular with web frameworks. We end up testing the database. So we store a model, then we retrieve the model, and we say, yeah, it works. Thank you very much. This means that Django, or whatever framework you're using, works, that Postgres works. But this is not what you are supposed to test. These are provided by a third party. It's not part of your core business. The second advantage is about customization, I would say. Look at this. In this case, I have two different use cases. One is to list items, and one is to list users. For some reason, for example, for performance reasons, I stored the users in a MongoDB, which is not relational. Okay, so I can't use it with a SQL Alchemy, for example, because it's not SQL. But this is not a problem in a clean architecture, because my use case is customized. It just has to receive a different object, okay, that is instantiated by the web framework. Pay attention that this might happen inside the same use case. So those use cases, those two use cases might be the same. And you might have some logic inside, might be part of your business logic, that says, well, in this case, I go and fetch things from repo A. In this case, I go and fetch things from repo B. Performances, for example, okay. But these repos are something that you get from outside. As you see here, I'm instantiated them in the web framework, not in the use case. And the other side of this is that the web framework is just one of the possible front ends. And with front end now, I don't mean React or similar things. I mean the way you present your results to the client. It might be a command line interface. It might be a web protocol or something else. because I just need to call the use case and translate the output of the use case into something that is meaningful for my front end. Okay, HTTP request for a web framework, something else, for example, text for a command line interface. Okay, at this point, I want to draw a comparison with an architecture that we, or at least many of you probably know, which is the Django architecture. Django is an amazing web framework, well known in the Python community. It has a different architecture. It's not the clean architecture. This doesn't mean it's unclean, maybe. Well, yes, it's unclean. Given the definition, it's unclean. What I mean is, I don't want to say it's bad. Okay, I'm coming back to this later. I just want to draw the comparison for now. Well, Django has models. These are similar to entities, superficially speaking. They just represent part of my business, right? I have items, I have, I don't know, books, films, something that I'm marketing. I have business logic, obviously, otherwise why should you use Django? You have something to market, right? Something to sell. Business logic in Django is usually implemented in views, but it can be implemented in functions that are called in views, okay? So this is similar, if you want, to what I did before with the clean architecture. Okay, for the first big difference. Django has an ORM, an object relational mapper, which is, if you want, a gateway. It's an interface. Because if you use MySQL, if you use Postgres, your views don't change, right? So you are using an interface. You are using something that masks the details of the underlying database. However, the object relational mapper, the name says it all. It is an interface to relational databases. And it's not easy to use Django with a non-relational database or with something else, okay, a web API, because of the ORM is customized for relational databases. And this is different in a clean architecture because the gateways is a more generic definition of interface. Last, two components, the database, which is an external system, which is also tightly connected with models, because models in Django can be saved and retrieved from the database natively. So the models are connected with the database. They are aware of the database. What is the drawback of this? That when you test your Django application, you need the database. It is possible to test it without the database, okay, but you are sort of fighting against the framework. You're doing something that the framework doesn't want you to do. So again, it might not be bad, but it's different, okay? So there's a big connection between two layers. One is the inner layer and one is outside. And the same happens for the web framework itself, as in the part of the framework that deals with HTTP requests and responses. Because that is connected with the business logic. As I said before, you usually implement your business logic in views, and views are specific things provided by the web framework. They are connected with URLs, right? Cool, so far, this is the Django architecture, just to show you that there are different approaches to the things. And as I said, this might be a good approach. It's not bad, it's just different. Okay, let's assume I convinced you, okay? In 40 minutes, you are like, yes, the clean architecture is the way to go. So I want to go back home and convert everything, to the clean architecture. Well, don't do it. So, if you want to do it the right way. So I always recommend to, remember what happened to Netscape when they decided to rewrite the whole thing from scratch. They lost everything. Have you heard of Netscape lately? No. Well, it resurrected at a certain point, but, it's a sad destiny, that of Netscape, and it's for a bad choice. So don't do the same choice. Migrations happen one step at a time. So my recommendation, if you want to try these concepts, is to isolate part of your system, something tiny in your system, and re-implement it, maybe with a clean architecture. Something that doesn't affect the rest of the architecture. Remember that when it comes to web applications, you have load balancers. They are your best friends. You can always route requests to another system, okay? And you can go back quickly if it doesn't work. Final slides. Is this the definitive architecture? So, done, okay, it's the perfect architecture. We don't have to do anything else. Go and implement everything with clean architecture. Thank you very much. So, the answer to this question is, in my opinion, the answer to any computer science question ever, and it is, it depends, okay? It depends on many things. It depends on your requirements. For example, when it comes to the clean architecture versus something else, for example, the Django architecture, I tend to show this slide. You are the crossroads between these two options, Lego versus Playmobil. On the right, you have something that works out of the box, and it's very nice. You can play with it, it's amazing, you know. I don't play with it nowadays, but I remember, I have fond memories. You want a farm, you get a farm. It's customizable up to a certain point. You can move things around, okay. On the other side, on the left, you can build whatever you want, but you are on your own. So it depends. What are your constraints? What do you want to achieve? Can you mix and match the two? Yes, you can. Okay, so this is my recommendation. Always, whenever you design a system, always stop and think. Look at the requirements. Don't go for a solution out of the box. It might be the right solution, but you have to be, you know, clear that why it is the right solution. Really, last two slides. I wrote a book about these concepts, clean architectures in Python. It's a free book. It's available there. The example I showed you today comes from the book. There, I implemented it properly with TDD all the way. A lot of error checking, so the whole book is about that example. Okay, just retrieving a list of objects. I implemented it with Postgres and MongoDB just to show that it's possible to use different databases. For the EuroPython, so for this week and the next week, I teamed up with some friends, and I'm offering the book and other books for free. It's a bundle worth of $60, so you are free to follow us on Twitter, and you can check the URL on Limpub to get the bundle for free. With that, I'm done. I hope it was useful. Thank you.
Yeah, thank you very much, Leonardo, for that very inspiring talk. We have a few minutes that are available for questions. So if anybody has a question, we have a microphone here, or just quickly go to that microphone and ask a question.
I'll be around for the next 2 hours, so feel free to get in touch.
Okay.
Yes.
Hello, thank you for the really nice presentation. And while I try to follow the layered architecture, the one thing that I always struggled is with, so if you want to really follow this, then it seems like you have a lot of duplication. So you have to have the models in the core of the business that your business or your cases are using. And then you want to persist also those models into the database or somewhere else. You then need to have some kind of definition of how this happens with some bookkeeping data, and potentially the duplicated definition of the original data. So it seems that there's a lot of duplication. So do you have a suggestion how to avoid that, or maybe make it less painful to implement the clean architecture?
I don't think there will be duplication. We might talk about this later. There is definitely a lot of message passing. So if that is what you mean by duplication, yes, the same data is going around a lot, which is part of the drawbacks of the clean architecture. There are a lot of layers. This might impact performances, like you don't have direct access to the database. But in terms of duplication, I'm not really sure what you mean. So if you want to expand on that.
For example, when in the example that you show for the Django, you define the model once, and then that's also the definition of how the table would look like. And majority of ORMs work the same way. So you have a single source of truth that defines basically the layout of the data in the database as well as the layout of the model that you're working with. And for the data-heavy application, that's really convenient and very simple to work with and define your system. So if you don't want to use that, then you need to have
I definitely see what you mean. Thank you. Now I understand. Yes, it's true that, for example, the model I use in entities, correct me if I understood the wrong way, is duplicated in the database interface because this is what I'm storing.
Exactly.
It's true. There is no way to avoid it because this is a feature. As in, I am splitting the model, the entity, if you want, as in a business entity, and the entity as something that is stored in the database. I agree, this is more work. And there is no way to avoid it because it's considered a good thing. Again, it's part of it depends, the requirements. You might think that in your business logic, this separation is not needed or it's overkill, and you're free to go with a different architecture. But the idea, if we want the extreme idea, is to split these two things because they might exist in the same space, but they are not the same thing. One thing is the business logic, one thing is how the business entity, if you want, and one thing is how I store it.
Okay, thank you.
Thank you.
Very quick final question.
Hi.
Hi, Leonardo. Thank you.
You're welcome.
I really appreciate your emphasis on beauty and art in terms of software. With clean architecture, I can see the benefits of, say, durability, utility. By making architecture clean, do I get beauty out of the box, or is there something more elusive, making something beautiful?
It might be a bit more elusive, beauty is to be defined. To be honest, when I was working on the book and I came up with the example and, I was looking at the projects where components were, how they were interacting between them. At a certain point, my feeling, and this is pretty personal, was like, this is really beautiful. It clicks, it works. And this is what I meant as in beauty for me. It might be subjective, okay, definitely doesn't shine, doesn't come in colors, but the beauty of that system for me is that it's, again, it's tidy. I know where things are. I'm confident that when I'm touching something, I'm touching just the little universe around that component and not other things. This works for me, and this is the beauty in that architecture for me.
Thank you very much for the questions. And let's have another round of applause for Leonardo.
Thank you.
We're going into lunch break now, and the talks will continue from 2. Thanks. Bye.
There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is, now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and other things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is, now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different society, EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming and saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is, now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and other things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is, now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and other things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and other things.
Knowing people and knowing many different society, EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and other things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is, now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and other things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That
All right, good afternoon and welcome to our next talk, 2 p.m. talk, Packaging Security with Nix with Ryan.
Thank you very much. I'm very happy to give this talk and discuss with you about two things I really enjoy and love, Nix and Python, and also security. So, just need to bring it on. So, just to start a bit of context, we're going to define what we are going to use for this talk. And just so you know, the talk is available at my GitHub repository and everything is there, demo, examples, and this various talk and its sources. So in Python, a package is usually a tree of files containing a special file. The name of the root folder is the name of the package, and you can import it under the right conditions. So you can tamper with the import paths or something. There were a lot of super interesting talk about different features which modify the way import machinery works in Python. And well, in some system, in some contexts, we actually do use those for legitimate reason. For example, in Nix, we use PTH files and sites to make it easy to import any package in an isolated way, like virtualenv enables you to do so. So everything we install from any PyPI-like server is a package, and every package manager you've used is also something that's provides for package and use these indexes. So now thinking about people like us, users, we install packages manually. We type in our terminal or by using graphical interfaces to install some packages. That could be NumPy, that could be SciPy, that could be whatever you need. And we do install those on a computer. We're running a certain operating system, and on this computer, there are things. Those things are some source code, SSH keys, personal file, professional file, secrets. And to us, they might be something that we don't care about, that may be something that we forgot that we have, but to other people, they might become valuable targets. And that's really important to think about this because the computer that we carry on contains very important data, and some people try to enforce the fact that you have to encrypt your computer to prevent for data loss and catastrophic failures. And we can also extend these kind of ideas to servers and deployments because they're kind of the same, except that you replace the human interaction by automation. So some valuable targets reachable at install time when you install a package are SSH keys, SSH servers, browser profiles, and whatever you name it. Because all of those are available in your user. So sometimes you can try to do things to isolate where you are installing your packages. So you use Docker or you use something like that. But not everyone does that. Not every package manager provides for package isolation. So yeah. Just a quick reminder how to publish a package to PyPI. We read down instructions to use our package, some metadata, and we perform some operations. I think it's really interesting that the most easiest way to describe how to publish a package is that at install time we perform some operations. Because historically, in order to install a package, you have to read down a setup.py, which is a fully complete Python program, which exposes an install command, and you can run everything in this install command. And this code gets shipped to PyPI and is run arbitrarily when you install your package. So maybe we don't really care about the fact that we can run arbitrary code at install time, but unfortunately, we have some example of annoying things and really bad things done with these fixtures. So for example, dateutil is a very known package to deal with dates. And some of you might remember the Python 2 to Python 3 transition, which was quite painful. And some packages which were not compatible with Python 3 started to create new packages compatible under the name Python 3-package. And of course, someone published the Python 3-dateutil package, but that was not an innocent package. So on 2019, someone published a malicious package behind this, which were depending on a jellyfish package and playing with a homoglyph attack, playing on the I or L confusion. And this payload tried to attack a very specific person, because if you unpack everything, gets the code extra, which is on the issue, by the way, you can see that it was trying to test if someone had a very specific file, which had not a very random name, or was not on every computer. So we can infer that it was a quite sophisticated attack towards one developer. So it's quite frightening and makes you wonder how frequent these attacks are, in fact. And some other talks about that. There are a lot of malicious packages which uses typo squatting, or even like, I think, honest typo squatting. Some packages were definitely downloaded too much, for example, DPP client. And recently, PyPI rolled out mandatory two-factor authentication for critical packages. And you might have noticed this last week. There was some drama about it, because PyPI did a great job, I think, giving out free two-factor authentication to critical package maintainers. But some maintainers didn't want to enable two-factor authentication, so they argued that it's something, it's like, if you're a maintainer of some package for free software, are you really concerned about the security of your users? And I think that's a philosophical question, so let's put it aside. The question we ask is why arbitrary code execution is needed. Most of the packages we install are mostly declaring their dependencies. So we say that NumPy depends on some numerical library and so on and so forth, and pip or any package manager use this to perform some topological sort and version resolution. But our formats, the way how we describe our package does not take into account the problem that comes with system-level dependencies. So when you install something like Beautiful Soup, which comes with a HTML parser, you need some XML parser, and you want a fast XML parser, so LXML is one good candidate, and it requires to install C libraries, so you have to coordinate with System Package Manager. You have also the problem when you're using numerical libraries such as SciPy or NumPy. You can change the inner acceleration to choose an acceleration which works better on your hardware. So for Intel MKL, you will get better acceleration on Intel-based processors. OpenBlast is the generic implementation which works quite fine for every processor which was wrote by the research. And you have the same for AMD and so on and so forth. Same for TensorFlow and CUDA, because you have some specifics about GPUs. And you have non-purely Python packages also, which are written in another language, such as Rust, must be compiled and exposed to your Python package. And when you pip install such a package and you don't have any will for it, you need to build it. And Python is not going to install a Rust compiler for you. So the author is going to install a Rust compiler for you. And you have many other examples of why this is needed. So we can argue that maybe that's the wrong model and you should do something else extra. But that's the reality, so we have to work with this. And this is possible because there is no real alternative to the problem. There was some interesting talk about the update framework and many other attempts to try to solve this problem, but not all can account for everything I just mentioned. And this is still very a work in progress. So one of the problem I think is hard here is that not only you have to support like Linux distribution which all have their way to do things. Some are source-based, you take Arch Linux, Gentoo, and so on and so forth. Some are binary-based, Debian, Ubuntu, etc. And they don't necessarily agree on who is responsible to bring you the final mile of dependency. And also, something I don't say is about Windows, macOS, and so on and so forth. And finally, software authors have to make assumptions. There are no easy way to discover some standards sometimes. So, for example, when you do a C library or native library, you can use something called pkg-config to discover library paths and pass parameters to your compiler. And that requires you to provide a PC file, and sometimes upstream developers forget about them, and downstream maintainers have to add them manually, but they don't necessarily get them upstream, so it creates a lot of fragmentation and difficulties to handle everything. So downstream authors have to do workarounds. Python developers, Python packager have to do something in their setup.py so that the experience is streamlined and very user-friendly. And as a result, you have a great success of using something like Docker and Friends because they provide a streamlined experience in a clean state, which would be here a container. So we could decide that, yeah, that's the state of thing, and we might need to restart packaging someday and do it fine, do it good, and get some 10 years milestone plan to get us there. But this talk is about Nix. So let's do a Nix crash course. What is Nix? So the idea behind Nix is a functional Nix language, and it's a general package manager, which is able to work with other package managers. The provoking idea of Nix is we break the file system hierarchy standard, so you don't get any /user extra. You only get your state file, so /home and so on and so forth. And everything is a symlink of something in the Nix store. So that makes it really easy to reason about what you have in your system. And everything is recorded, and you have a cryptographic hash. We'll come back to the cryptographic hash later. Packages are not really packages in Nix. We don't have any concept of packages. We have concept of derivation, which is a more general concept. And we express something in the Nix language and produce outputs. So that can be a package, that can be a systemd unit file, that can be a bash script, that can be a Python script. Everything goes. So here's an example of file system hierarchy standard. You can find those SBIN, SRV, USR, var that you often find on your system. But on Nix, those either don't exist or are symlink of a special Nix store path. So just to get some example of what is Nix, here's the Nix language now. So this is an expression to build a Python package. So you have some import of the package, the list of packages we have. So this is a function signature. We have a function call. We call the build Python package function. We give a name, we give version, we give the source. Notice that we give the hash. That's something that prevents, in Nix network access is disabled, except for derivation which have a hash so that we can already know the result in advance. So if PyPI tried to change the contents, the result would be rejected because the hash would change. So this protects us a bit, but not a lot. And we have some metadata about the package. So the Nix path. So we said that we have a Nix path. Here is the cryptographic hash. A nice property of Nix is that this cryptographic hash uniquely identifies your package. Either things are input address, that means that your package is function of the inputs. If you change NumPy and you depend on NumPy, your package is going to change. Or either content addressed, that means that either if NumPy changes, but your result won't change because it's a minor API bump or something, the hash won't change. So that's really interesting because you never build software twice, except for very good reasons. And that makes it trivial to cache derivations and provide them to everyone. And then you get a nice name. And now you get something that you all used to, which is the bin folder, the lib folder, etc. So here's some glossary, basic glossary of the Nix terms. I'm going to go fast on them. The Nix store is the file system where everything is recorded, including the derivations. The store path is either outputs produced by a derivation file or a derivation file itself. So you can send derivation to someone else and he can build it for you and you can get the outputs. Derivation is the receipt. So when you say, I want to build tools like we've seen earlier, you say that this is a Python package and all Python packages have a way to be built, which is running the setup.py. and then we just give some parameters that we need, so the source, the name, the version, some metadata. And what is interesting about it is that even a full NixOS Linux system is just one big derivation, which is your kernel, your initRD, your boot script, extra, and you can have a tree, which I will showcase later, of your whole system. And then the mathematical concept of closure, which is that when you have a binary relation such as software X depend on software Y, often in the packaging ecosystem, you want to get the closure of this. So you look at the graph and you say, okay, I'm going to get all the packages I need, which depends all on themselves, so that I can have the full software package and working on my computer. So in Nix, we often talk about closure of a software, and that means the transitive closure behind the binary relation of dependencies. So now maybe I lost some people of the audience, and maybe a question I would ask is, how many people are using Nix here? Yeah. Well, that's cool for all the newcomers here. So maybe it's a bit obscure so far, and it's very normal because that's how Nix is perceived by a lot of people. And one thing it tries to do is to use theoretical framework to get the complexity of software tamed. So as a goal, Nix has always have had build reproducibility. So what I explained about input at rest or content at rest. So once you build a software once, you can retry to rebuild it and you will get the same very package. Something later on that will be funny. And build operation are sandbox by default. So no network access, no arbitrary access to the user file system, or even installed dependencies. I cannot try to see if you have, like, I don't know, NumPy installed if I don't need NumPy. So that's pretty powerful because it will help us to see what the software is actually doing in the sandbox. And you still have escape hatches. If you take some software like Steam, well, Steam is a very bad behaving software because it brings its own libraries because it's trying to solve the problem of libraries. So some games are not statically linked. They come with their libraries, and Nix doesn't take the library of others. So we have to make it pretend live in a file system hierarchy standard using namespaces. And yeah, everyone is able to use Steam on NixOS, even if it looks like quite hard. Composition with local package manager is interesting and important. Nix is not about reinventing the wheel. It's not about like taking over pip or poetry. It is trying to work with pip and poetry so that it can handle the thing that the distribution, the Linux distribution has to handle, while pip and poetry focuses on what it has to solve. And trivial caching. As we have reproducibility, Nix provides a very big binary cache which has everything you contain. So even though NixOS is a source-based distribution, you don't recompile that much. I think the only time I recompile is because I'm changing something in the C compiler and I'm recompiling the whole word. So I think that this chart for ripology.org shows something very interesting, that Nix has a lot of package projects and non-unique package projects. And of course, it's because we are automating a lot of packaging, and we are like eating packages from PyPI and so on and so forth. But we're doing that with a lot less maintainers than something like the Arch Linux user repository. And I think that's very interesting to see that, because we have a lot of data on what is packaging, what is a package, and how people use this package, and what does this package does. We have a minimal image. We have came very far on reproducibility on that, and we have only 2 paths which are not reproducible. So this is the website tracking NixOS reproducibility. So it's trying every path that is a derivation in the minimal image and trying to see if it can rebuild it twice on a different kernel, different hardware, different machine, different time, and see if there are any differences. So so as you can see, Python and Rust something are not reproducible. Sometimes we're at 100% and sometimes we're not. So it's continuously test. And as you can see, we can look very deep into the problem and see that some PyC file is changing when we're rebuilding twice. So maybe a non-deterministic optimization or timestamp related issue. And that's pretty cool to be able to do that. So the question now is how we can leverage Nix as a tool. So as Nix is very strict and the world outside is quite forgiving, we have to not re-implement the wheel, we have to reuse existing tools like pip and poetry, but we have to let Nix handle the downloading, the native dependency sourcing, and capture something in a Nix expression. And we put pip and poetry and every tooling that we use like this in an offline mode. That means that we instruct pip to say that we're going to do an offline install and should rely on not using network access. So for now, I'm going to use a very simple demo of that. So here's a Nix command where I'm going to create a shell. So Nix shell is very interesting because it's you're all used to virtual env. Well, Nix shell is virtual env generalized to everything. So you can use any package, any binary temporarily in some sort of virtual env, and once you exit the shell, those packages are not in your environment anymore. So what I'm going to do is to have a Python 3.9 environment with some known to be annoying package to install sometimes on some systems, and show that it's quite easy and what happened when you do that, of course. So you can see that I made a rookie mistake, which is assuming that bash was available in my path. It is not. I have to use env, which is the POSIX standard for that. And you can see that Nix is going to compute the closure of the packages I asked. So I have some nice information about the download size, the impact size, and get everything that I need. So it's doing the work and downloading. And now I'm creating the environment. So I'm in the Nix shell right now. So I do have NumPy. I do have SciPy. I do have TensorFlow. And PyTorch. Once I exit this shell, you can see that I don't have those packages in my environment. So it's indeed working. And I can perform some advanced stuff on this thing because I can change the inherent numerical library. So I can do Intel MKL based NumPy or SciPy. And it's quite easy. This package, this script can be cached so that I can share it with others and they can have the instant shell and not download, not build a lot of things. So it's quite cool. And continuous integration becomes a lot easier to test with these kind of features. And the second demo is about a self-contained script. Sometimes we build some scripts, one file script, sorry. And we don't use external dependencies because it's annoying to package them or to package a one file script with dependencies. So here's an example with request. So I just want to do request get EuroPython.io. I don't have request in my environment. I don't want to install request. I would like to share this file with friends that might use this package, might use this script rather. And you can see that my code tool is not finding request. But I can still run it and get an answer because Nix shell can be used as an interpreter for shebungs, which is a feature of the shells. And this way, you can do self-contained Python script trivially. So we've seen how Nix can be leveraged as a tool for doing Python development. We didn't showcase how to do Python deployment, but the idea is the same. You build some closure, you send it to the remote server, and the remote server just use it. You can do a lot of advanced stuff meanwhile. You can check that the closure is coherent with something. You can sync the closure. You can generate a software bill of materials, and a lot of stuff. But the problem with Nix is that its learning curve is quite insane. So not a lot of people are that much graybird, but some tries. Nix is like very frustrating for new users used to download binaries from the internet and trying to run them. We have solutions for that, but it's still not easy. And Nix cannot solve everything. So Nix cannot solve things that were not built for Nix, meaning that we have a system to determine which packages is hit by CVU. But have you ever seen a CVU informing you about the very function who is affected in the security vulnerability? So you cannot like say that this particular function which is affected, this is the hash of this function, this is the hash of the code. So we cannot automate easily whether we are affecting or not by a CVE. That's something which is a work in progress. CVE are very granular. Sometimes they say to you that in your dependency you have a package who is vulnerable, but in fact you're never using the package, so you're not affected. And Nix cannot solve that. Tooling that takes log files and produce Nix expression are not enough. You have a lot of edge cases, including in the Python registry. Sometimes some URLs are not stable, and you have to try to predict things and try to find out about hashes and so on and so forth. So it's a bit difficult. Today, there is a bug on poetry, which breaks a lot of things. And I just got hit by it, and I wanted to do a third demo, but it doesn't work. Limits of the standards are also complicated to work around. If you take a crate like cryptography, which is a Python package for doing crypto, we have to do this kind of workaround to support it because it brings a Rust compiler in the play. And unfortunately, the files doesn't bring any hashes about the hash of the dependencies of the Rust project. So we have downstream to support that and try to work around behind the fact that if you're under a certain version, we should use the wheel. If not, we can compile it. And here are the dependencies hashed, and we can use it, etc., etc. And it's very, very complicated. So we have been working with cryptography guys on that, but the format doesn't support it, so it's hard. And advanced attackers would just move to backdoors. And now it gets very complicated. It's not a technical problem. So we need, in the future, more foundational work to be compatible with Python. We disable bytecode optimization because of those are not determinism. We're not using a lot of wheels because it's super hard to get right the many Linux ABI problems. But at the same time, we have things like TrustX, which solve distributed trust issue. When you have multiple binary cache, how do you trust this binary cache? What is your policy? Do you want to do majority vote? You ask every cache what is their cryptography hash, and you say that if the majority vote in favor of a hash and something is not doing it, then you reject this cache. So it's quite interesting. We have the Salsa framework, which is a framework pushed by some big corp tech companies to get high level of assurances in your supply chain. In integration with the ecosystem are being published at the moment. So the conclusion is installing packages in Python is dangerous by construction. Fixing this is complicated. Attacks are running in the wild, and we can only measure the public surface. Raising the cost for attackers is quite easy by constraining the attack surface with Nix at least. And the real win are, in fact, that we have a lot of data produced by Nix. We have the integration with the external ecosystem. Doing multi-language project becomes easier with Nix. And that's pretty much it. I will left you with some references and do some QA if I have time for it.
We unfortunately are out of time, so there's no QA, but thank you so much for your presentation. One, there's a slight delay due to some technical issues. Just a few minutes. Never mind, we're good to go. All right, introducing automated refactoring large Python code bases by Jimmy. Thank you.
Hello, I'm Jimmy. I'm a staff software engineer at Kata. So today I will talk about automated refactoring in large Python code bases. We have a large code base and we want to solve two problems, code formatting and type check-ins. Those are common Python code base problems, but it's especially challenging in our large code base. So we are Kata, so it's a financial service provider. So we provide online tools for startup founders to issue stock options to their employees. Or when investor invests money on startup, investor get stocks from the startup. So all those different people, they can use Kata to manage their equity. And other than those, they can also trade and also get other services on top of this platform, including compensation, valuation, tax, and fund admins. So we have a large code base that has developed for 10 years. It's Python code managed in Git. It has more than 2 million lines and 30,000 files. Every day, 200 active developers continue to commit changes to it. So with such frequent updates every day, it will be hard if we want to commit a large change. Let's say we want to modify 20,000 files at the same time. It's hard to merge this change because it will be basically conflicts with everyone's change. And let's talk about code formatting. So Python provides pretty flexible code style, so you can write the same code in very different formats. So in this example, the red block and the green block, they are actually the same code in different formats. You can use single quotes versus double quotes for string, or use different indentation to wrap or unwrap the lines into multiple lines, or combine a lot of things in one line. In a large code base, if every developer, they are using different formats, then the code base will be less easy to read. So we will want to apply a consistent format. That way everyone can read and write fast. So luckily, there's a popular tool, Black, for that. And we want to apply Black in our large code base. And it comes with the problem we just talked about. We couldn't just run Black on our large code base all at once. It's hard to merge such big change. And what if we take a different approach? We split the changes as smaller pieces. Each one only modify like 20 files. Then we can incrementally convert our code base into 100% Black format coverage. So this approach may work, but it comes with other challenge. It will introduce actual work. You will need to spend some effort on creating and managing those small changes. You also need to make sure those changes, they don't overlap to each other. And another challenge is, since it's an incremental process, we need an effective way to make sure the developers don't introduce regressions during this process. If some developer, they reformat the code into a different format, then it's causing regression. And we also want to apply type checking in our code base. So in Python, it's common to get a lot of type-related errors, like attribute error, type error, or value error. It's because Python is not a strong type language. And one effective way to catch those is to get the help from MyPy. So if we have MyPy type checker running, it could have make those suggestions like the blue box and help our developer catch them. but in order to get MyPy working, we would need to add type annotations. So for each function definition, we would need to add the annotation for each parameter and return. And those are the work that looks simple, but in a large code base, it's challenging because in our code base, there are more than 100,000 files. 100,000 functions. That means type annotation. And if we would need to manually annotate each one, it will take forever to finish. So that's also challenging. And our solution is to use automatic refactoring to solve all those problems and challenges. So the idea is, what if we can automate those incremental code changes? If we can do that, we can solve large-scale tech debt problems in large code base. And let's take a look at how a code change life cycle looks like. So this is actually how our developers do their job every day. They will take some code paths that they want to apply some code change. They make the code change, create a pull request, then it will kick off some continuous integration tests, and the test may pass. Then they will want to add some reviewer to review the change. If the test fail, it could be the change is wrong, so it should be remade. Or it could be just flaky test, then maybe retry after some time, we'll make the test pass. And after adding reviewers, if we get enough reviews and approved, we can merge the change. Otherwise, we may need to add more reviewers, or sometimes need to notify the reviewers in another channel like Stack. And sometimes we also need to rebase the pull request to apply the latest change from the main branch, or merge, or when there's merge conflict, we need to close the pull request and then recreate a new one later. And so in this life cycle, we want to automate everything. So the pin block are those we identify can be automated. So we want to build a automated refactoring framework to automate those. Then let's talk about the design and the implementation of this framework. So there are several considerations we want to design. The first one is the size of the code change. We want to make sure each code change is not too big. Otherwise, it's not easy to review. It's not too small. Otherwise, we will need to create too many pull requests, which introduce too much overhead. So one way to solve this is to just while we walk through the file tree of the large code base, we can count the number of Python files in a subtree, and we only take the subtree as the target code change path when the number of files is less than our defined threshold. So this is one way to implement it. Another consideration is the number of pending pull requests. If we create too much, then we will introduce too much work to our developers, because they still need to do their daily job. If we create too many, then they would need to spend all of their time on reviewing automated pull requests. They won't have enough time to do their work. And if we don't create enough, then we won't be making progress. So one way to implement this is we can potentially add a consistent label automated refactoring to each created pull request. That way we can use the GitHub command line tool GH to do a query like this to search all the pending pull requests that has this automatic refactoring label. So we can run this query to check the pending number of pull requests. and only starting to create more when it's less than the desired threshold. And the next consideration is we want to avoid duplications for each code change. So that is to avoid conflicts. And we can encode the path that we are modifying as part of the pull request. One way to implement this is to encode the information as part of the Git branch name. So, for example, for black formatting related changes, we could potentially use black formatting as the prefix and the target directory name as the postfix. And another consideration is incremental adoption. So we want to avoid regression while we adopt it, so we can introduce an enrollment process. So the idea is when a file is black formatted, we add the file path to an enrollment list. So it's a text file that consists a lot of paths. That way, we set up a continuous integration job that always run black formatting check on all the files on this enrollment list. So we can make sure no future code changes can break the black formats on any of the file. So with this approach, eventually we will add all the files paths into this list. Then at that time we can remove this list because we reach 100% coverage. This same approach can also be applied on type annotation adoption process or any other problems. So in order to simplify the implementation, we can implement each pin box as independent jobs. So let's think of this as a production line. So each job is an independent job that moves the pull request from one state to the next state. So it's like state machine transition. And so if we make each job independent, we can just run those jobs periodically. So that then they can just move the pull request forward to the end of the life cycle. And what are the jobs needed? We need a job to apply code change and create a pull request. Another job to check the test status and add a reviewer if it passed tests. Another job to check the review status and add more reviewers, or send Slack notifications. And if it's approved, another job will merge the pull request, and another job to close the pull request if conflicts happened. And we also need to provide an API for our application, the refactoring applications. For example, we can use Python abstract base class to define an API, refactoring applications. And then an application like black formatting can just focus on implementing the API to provide needed metadata. So the metadata we would need when creating the pull request, including the pull request title, the labels we want to add, the body, the commit message. So with those, we can provide enough detailed information when creating the pull request. Then the reviewer can just, based on what we provided in the pull request, to review the change. We can implement the two different functions. The first one is skip a path, because we know it's an incremental process. So we want to provide a helper for each application to decide whether they want to work on a path or want to skip it. And for black formatting, we talk about using an enrollment list. So black enroll.txt. So we can just use a helper to check whether this path is already enrolled. If it's enrolled, then we want to skip. The most important logic is in this refactor API. So we want to do two things. The first is given the path that we want to apply, we want to refactor, we will run black command. And given the path, then black will format the entire path. And the second step is to add the path to our enrollment list. So with an API like this, the application just need to focus on the metadata and the refactoring logic. And the remaining work is taken care of by the framework of automatic refactoring. So in order to implement periodical job, we can use GitHub workflows. You just need to add a YAML file like this in the GitHub workflows directory in your code base. With this config example, you can set up a job to run every 30 minutes during the workday, and it runs some Python code. Let's take a look at some job examples. So first job is to apply code change and create a pull request. We can use PyGithub to create a pull request easy. When you use GitHub workflow, you can easily get the provided GitHub tokens and get the current GitHub repository name to set up the PyGithub library. Then the main logic here is to basically walk through each refactoring application by calling the subclass helper. For each application, we want to check what's the current pending number of PRs. Only if it's less than the desired threshold, then we will fetch the next path and then run the refactor logic. And then we will, after that we already refactor the code, we will commit the change and then create the pull request. And when creating the pull request and making the commit, we are using all the metadata provided by the application. Another example job is to merge the approved pull request. So again, we are using PyGithub to make a query to find all those approved pull requests. And for each found pull request, we can just call the merge helper to merge it. In the earlier example, we used black command to refactor the code. You may want to build some custom refactoring yourself. In that case, we can use some other tool. Let's take type annotation as example. So let's say we want to add some missing types. Some of the simple functions we can base on simple heuristic and inference to add the missing types. For example, some functions like init function, they don't have any return statement. We will want to add return now. And some functions, they only have one single return statement at the end, and it's returning a simple string, like this get bar function. We will want to add str as the return type. So we can use libcst to implement a transformer to do this refactoring for easy. So in libcst, it provides some helper to help us convert the source code as a syntax tree. So we can call the parse module in our refactor logic to convert the text as a syntax tree. The root node is a module. Then we can call our transformer add missing non-return to convert the syntax tree to add the missing non-type. And then eventually we replace the original file as the updated code. So the logic are in this add missing non-return. So it's a transformer which allows us to register some callback function to be called during the tree traversal. We can define visit function definition function to register a function. It will be called whenever we enter a function definition node. So with this, we can implement this. So basically, we need a counter, which is the return count. We initialize it as 0. Whenever we enter a function definition, we also reset it as 0. And then when we found a return statement, we increment the counter. And then at the end of the function definition subtree traversal in the leave function, we will check whether this current function definition is missing return type. And if it's missing return type and the counter is 0, that means this function return nothing. So we can safely add the return annotation as null. So this is a simple example. So we can build more complex refactor. And some other more complex dynamic types, you may want to get help by collecting runtime types. So we can use monkey type tool for this. Monkey type is an open source tool. You can run your program along with monkey type to collect the traces of each function call. And then you can run monkey type command to apply the collected types to your code. So with this, you can just run monkey type in the refactor step to apply the refactoring. So we already covered the implementation, and let's talk about how it works in Kata. So for black formatting, we made black tool available in our code base in 2020, but after a long time, not much people start to use it because it required manually run black. Until we start automatic refactoring work, we were able to quickly ramp up the coverage to 100% in a few months. So now our entire code base is in black formats. Similar pattern happened in type annotation. So our type annotation coverage, it was growing pretty slowly since 2019 until we use automatic refactoring to add the missing types. We were able to quickly increase the coverage in a few months, and we are still continuing the work. While we're working on increase the type coverage to make MyPy more useful, we have seen the number of type errors in our production environment decreased over time. The number is fluctuating. It depends on the users and the traffic to our service. Yeah, but we do see trending is decreasing. So here are the summary of the talk. So automatic refactoring is useful if you have a large code base and many tech debt to solve, because the automatic refactoring framework, it enables you to save a lot of manual effort. It also allows you to fix tech debt problems incrementally and continuously. And it's not only applicable to Python. So when we implement our framework, we make the API extensible for other programming language. So we are actually also using it for TypeScript in Kata. So that's it. Thank you for your attention. So if you are interested in more technical things in Kata, we have an engineering blog on Medium. We also have a lot of jobs opening. And for all the tools mentioned in the talk, you can find the links here. So that's it for today. Is there any questions?
Yeah, we do have a couple minutes for questions. Would you like to come up?
Hi, thanks for the talk. A question from experience. So in large monorepos or in large repositories, oftentimes you end up with multiple copies of the same files, modules, etc. And each of those copies can then develop a life on its own. So during the refactoring phase like this one, what's your approach for identifying the duplicates and dealing with duplicates that may have diverged by then?
Yeah, I think duplication is it's a common problem in large code base, and based on my experience, I didn't solve this problem yet. Yeah, but I know some people may use some tools to detect the duplications like SonarQube, and then just analyze the code and try to fix the duplicated code manually, but that is not scalable. Yeah, another approach we did is we try to develop some tools that can help us I mark some piece of code as deprecated code and forbid the other people to use it using linters. So we do develop a tool called Decomposition Toolkit to help our developers use it to mark the code, and then they can track the progress of, they can count the number of references in a dashboard, and then eventually the linter will prevent new reference. Yeah, that is my experience.
Hi Jimmy, great talk, thanks. So it seems like this framework would be pretty useful for anyone running on GitHub. Any plans to open source it, or are you aware of anything already open source that's in similar state?
Yeah, that's a good question. As far as I know, I didn't know any service like this is open sourced, and in our implementation in Carta, we started the implementation with Circle CI, not GitHub workflows. Yes, so I think it's probably more easier to use if it's implemented in GitHub workflows. So that is something I will consider to discuss with my team to make it open source. Yeah, because other than the implementation of the workflow, we did implemented a lot of Python helpers to make building the framework easier. So that library could potentially be open sourced.
Well, that's all our time, so thank you so much, Jimmy, for your presentation.
Thank you.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and other things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different society, EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Okay, so I'd like to present Dr. Arjuman and Dr. Atif for this next presentation, Python for Arts, Humanities, and Social Sciences. Thank you.
Thank you very much. Hello everyone, my name is Atif, so I'll be presenting the first half of the talk and then Arjuman will be speaking the later half. So the topic is around Python for Arts, Humanities, and Social Sciences. Both of our backgrounds in terms of the training is coming from computer science, but both of us are applying now Python and also CS as a whole in arts, humanities, and social sciences. The talk is organized by following content, so we are going to touch base on what is AHSS, a bit on our experience and exposure coming from data science, artificial intelligence, because it's very dominant, and there are some data science roles where there is a difference between STEM and AHSS, so I'll just throw a bit of light on that. Some bits on Python and technology, followed by case studies, which would be covered by Arjuman. So arts, humanities, and social sciences, you know, the academic counterpart to this is STEM, where we know like science, technology, engineering, and mathematics. But when it comes to arts, humanities, and social sciences, this is where the user or the human exists. And a lot of the time when we are trying to solve a problem, it's mostly about humans. So if you're even trying to solve a problem from computer science, we're trying to solve a problem that exists outside of computer science mostly, which is why we see a lot of interdisciplinary roles within computer science as well, and applications and so on and so forth. One of the challenges that we have when it comes to arts, humanities, and social sciences is lower attention has been given to this because there has been drive towards STEM more often. However, the problems are now coming from AHS more often than it was coming before. Within universities, arts, humanities, and social sciences, they get less attention compared to STEM, but recently there is a change, there is a drift there is a push towards arts, humanities, and social sciences in Europe and also abroad. However, searching for a common good in the domain of humanities, it's a big thing for the causes such as social good, social welfare, and for the society, for uplifting it, for futuristic smart cities and all those kind of things. But the whole point here is human in the loop, or we are trying to solve a problem for the human. That is where the humanities is quite important. In UK, it has been rebranded because the attention has not been given, like as soon as people hear arts, humanities, and social sciences, for some reason there is a stigma around it in the minds of the students and as well as in the society. So they tried to change it and bring it shape. They call it shape, which means simply social sciences, humanities, arts for people and the economy. And of course, when there are people, there is society, there is economy. Now, when we see a big picture, when we talk about data science or maybe perhaps artificial intelligence, we see a lot of intersections here where a lot of things happen. For instance, if I show you there is computer science, and when we try to merge it with business or business problems, we have traditional softwares such as Excel, such as PowerPoint, because they're kind of the tools that try to solve some of the business problems. But when we try to mix computer science with maths and statistics, this is where we usually see machine learning. And when we try to mix maths, stats with business or any domain, which could be arts, humanities, and social sciences as well, we kind of get data analysis where most of the traditional research takes place. But when we combine all these three together, we kind of get what we call data science, which is where you have computer science as a tool, and then maths and stats kind of provide you with a theory, and then business or the domain provides you the context that you're trying to solve. And in this intersection, there is a great support coming from Python, for instance. When we talk about statistics and analytics, these are the two of the common terms that are being used. When we talk about statistics and you talk to a computer science person, they might be talking mostly about descriptive statistics, or perhaps EDA, exploratory data analysis, if you may call it that way. where the idea is to look for or describe what has happened in the past rather than predicting what's going to happen in the future. This is what traditionally is declared as descriptive statistics, which is kind of also my background in the sense because I'm coming from computer science. The other side, when you talk to a person who's coming from a computer science background, they might be interested in something which they call predictive analytics, which is where they're trying to use the data and trying to predict something in the future. Where there are other two areas where mostly arts, humanities, and social sciences people are interested, which comes from statistics, is around inferential statistic, where they're trying to build a hypothesis and they're trying to test it, which is a little different from what we do in predictive analytics, where we are trying to predict the future. Likewise, there is another discipline where business and arts and humanities and social sciences people are interested, is called prescriptive analytics, where is the domain of like what should be done, simulation, rule-based approaches to trying to solve a problem, or perhaps recommending a different path. The interesting bit over here is when we discuss about Python or the application of computer science or the application of data science, you can see all four of them playing a huge role. And if a person is coming from computer science, mostly they are in these two areas which are like pointed out with the arrows. Whereas if somebody's coming from statistical background, they would be more inclined towards these two. Then there are a lot of applications of AI now when we talk about, like as I've mentioned earlier, computer science is not solving its own problem as much as it's trying to solve other problems. So you can see we're trying to make traffic experience better through automobile applications, trying to solve problems of the business, education, finance, manufacturing, gaming, government, healthcare, you just name it. Like the applications are limitless, but most of them come from the domain expertise which are outside of computer science. Now, when it comes to data science, there are two distinct kind of roles. First of the type of the role that I say more suited towards STEM people, but there are other kinds of roles that are suited more towards AHSS. So when we talk about somebody who is a data scientist, and of course, when we talk about data science, we talk about Python automatically, okay? Because Python is the dominant language here as well. So when it comes to data science, it means like the person will do almost everything from visualization, from collection of data, analysis, presentation, and everything. If the person can do that, we call that person a data scientist. However, we know that having an all-rounder, best all-rounder, it's like very difficult to achieve. So you might come across people having stronger abilities in one of the identified areas. For example, they might be very clever when it comes to analysis, but they could do a bit of visualization and so on and so forth. So it's like it's in demand. Lots of companies want to have a data scientist. Then there are machine learning experts who are mostly about creating new methods, trying to create new models, doing a research breakthrough kind of a thing. They're always trying to chase something around an improvement of the accuracy and so on and so forth. They might be coming from an academic background, and they might be just trying to publish their new research. So they are in that area. So these two are mostly STEM roles. Then we have data engineer and data architect. These two are about how can we build the pipelines on the data. So how can we manage the data and the SQL and the storage and all these kind of things, or the big data. There is a subtle difference between data engineer and data architect. Data engineers are the ones that are responsible for designing and developing and maintaining the entire data pipeline, test the ecosystem which is required for the businesses, and prepare the data for everybody else who is in the team, but mostly for data scientists. Whereas data architects try to give a well-formatted data, produce a schema, thinks about how to bring in structure so that everybody can access the information through a structured way. But again, these two roles are STEM as well. Then there are database administrators, which are commonly known to businesses as well. These are the people who can pull out information from the databases. And they are, of course, of STEM as well. Then there are technological specialized roles, such as NLP expert, deep learning experts, and so on and so forth, whatever is required by the industry. Again, mostly they are coming from STEM areas. Now, there are other roles when we talk about, such as data analysts, such as machine learning engineer. They are more suited towards AHSS. However, they might be coming from STEM too. there is a blurred boundary here. But if you see from the point of view of analyzing something in the context of business, and if they don't understand business, or if they don't understand the importance of the human who's behind that, then performing such an analysis or performing a visualization and trying to analyze what is important becomes very difficult. So you have to become more expert of the domain, and then you should know the right tools just a bit, instead of showcasing that you know a lot of tools. You just need to know a few tools, but really tell the story. In terms of machine learning engineer, who's a different role compared to machine learning scientists. Scientists are trying to chase for 1% accuracy boost, come up with a new modeling strategy, whereas engineers are the ones who are trying to plug in what is already available in machine learning and then try to solve a problem. That's where they understand the problem more than they can develop more of the machine learning and advanced machine learning in terms of the theoretical space. Then there are people from data, storytellers, those who can tell the story from the data, and they can inspire people or businesses, and as well as society, wherever the application is. And that's where they need to connect with the real society or the real people who are going to benefit from it, and that's why it belongs to AHSS. Likewise, there are people from business intelligence development, and they are called BI developers. They understand the business, and they just try to tell the story or try to solve the problem for the business. They might not know much of data science in the details, but they do understand just enough to make use of the tools which are available to answer the queries for businesses. Now, when it comes to Python, we have a great support for machine learning algorithms, just to show you, like, this is how it looks like, right? This is just a small subset of how the real support that exists within Python as well. These are all nearly algorithms which are all supported in Python. Now, you can see with scikit-learn, there is a path from where you can start. You can think about how you can, if you have such a data set and if you want to grow from there, what is the pathway that you should take and try to solve the problem. So there is a strategy, there is a cheat sheet which is available, and of course it's growing as well. It's just to highlight what exists over there already. Then we have different types of neural networks. You can assume that as a rat's brain is different from an elephant's brain, from a monkey's brain, from a human's brain. Whatever is suited, you just need to borrow that and try to solve the problem. If the problem looks like a rat's brain is enough, so you need a small neural network to solve that problem. Whereas if the problem is different, you have to go for a different architecture. So there is a variety of choices that exist out there. Now, the problem, what has happened over the last couple of years is we have lots of technology, and some of the quotes that I would like to point out over here. We have lots of technology available. Now it's mostly about the right selection of the technology for the businesses to benefit from it. So we don't need to say, yeah, there is another technology out there, so what? So the problem here is, what is the right set of technology? Another thing is computer science has become more like a calculator for the other disciplines. But the problem here is this calculator is quite different from the calculator that we knew, a few years ago or decades and, centuries ago. And not centuries ago, but decades ago. So this requires a person who understands it and then, prescribe what you need from it. Another thing is computer science is kind of analogous to the spice of a cuisine. And that cuisine actually belongs to different disciplines, which could be outside of computer science. And if you put too much of a spice, it will spoil the dish. It's like too much of a technology will not be good. And if you don't give it enough technology, it will sound tasteless. And this is where Python is quite good, because it has a lot of support, and it just requires people to tailor it and then prescribe it as a solution for other disciplines as well. So Python is not just for computer science, but of course beyond for that. And here I'll stop and hand it over to Arjuman for the rest of the part.
So my colleague covered what data science is, why social science, and the boundaries are blurring now. But when it comes to actually teaching programming and Python to the arts, humanities, and social science students, there are quite a few challenges, and the topmost of which is that there is this fear within them, like the Minion shows. So the real issue that we face, coming from a computer science background to an AHSS school or AHSS students, is how to make students overcome that fear. So over my 1-year exploration of this area, or maybe 2 years, what I have learned is that don't make them think so much about the programming task at hand. Give them what they want in terms of their social science problem. Curiosity-driven exploration, because they are solving social science, humanities disciplines are about solving problems of humanity, problem of society. So tell them, okay, this problem that you want to solve of society, you do surveys, you do interviews. Computer science has the right amount of tools, not just the right amount, but also a mix of different tools that can help you get the data, do some analysis, EDA over it to make your job easy. And that's when they stop thinking about the fear aspect of it and get curious towards how that technology can give them more insights. For example, this is a postdoc position advertised by an interdisciplinary team in Germany. Now you can see that the topic is politics of inequality, which is coming from a social science problem. But they want somebody who also has a background in Python, in some of the technologies. So this is the kind of work that's happening in research departments. This is the kind of research problems that computer scientists or social scientists with a little bit of technology can solve. So if you motivate them that, okay, let's take a problem of society, which I'll also explain as I go on, which I did with a business school and also in another project on immigration. But first, another thing to make their fear go away is to break that problem down into smaller problems. And for each set of problem, give them a notebook or a small demo. That fascinates them and makes them less worried about the programming and the syntax stuff. And that has worked a lot. Now this was, it's available on my GitHub. So during the last year, I taught in a fintech module at TU Dublin, Technology University Dublin. And being from a computer science background, it was slightly my first experience. And I was like, how am I going to teach business school students? And their background was of a right one. There was a rugby player in my class. There were 2 students from direct provision. So those of you who don't know, direct provision is Ireland's asylum system where refugees are housed. So there was huge, and 2 or 3 were quite good in programming already. So to take them all along in one class was quite a bit of a challenge. Some were at times nervous that the students who already know programming, they're not letting us learn. They're going too fast. They're answering all your questions, stuff like that. So, and then I had to come up with something that would be challenging for everybody. Not just those students who were already familiar, but also those who wanted to study the business side of things, the finance side of things. So anybody who's in finance and business knows that Tesla is the hot thing. So I created this project about Tesla news articles. I scraped some news articles and they had to do sentiment analysis over it. And then use those sentiment analysis features as predictors for the company's financial performance. Another thing that helped was providing them with starter code. So I gave them skeleton code. At first they were struggling, how do we even start? How do we read those files? How do we read the CSVs and get the sentiments? And so that part, if you go to my GitHub and you want to teach finance students this project, everything, the whole instructions is up on my GitHub. I'll also share on Twitter later. So this worked really well. And the students were towards the end, they were very, very happy that we solved a very nice programming project. And when I saw their reports, it seemed as if there was also a part where they had to do, different feature engineering. And a lot of them put, well, not everybody, but some of the groups put in a lot of effort into that. And that help bring out their creative side. So it was a very good experiment. This project is funded by Irish Research Council, and they are the other main funders, and it's called Inclusive IRE. IRE is short for Ireland. And it involves School of Business in TU Dublin and School of Computer Science in UCD. So the whole idea is that what we are doing surveys and focus groups and gathering quantitative data from that part and applying those insights to social media, gathering data from social media to develop a tool for detecting sentiment around migrants in Ireland. With time, especially during COVID, it was noted that Ireland is getting less friendly towards migrants. This wasn't the case a few years ago, but it has increased. Or maybe it was, we never knew. Some aspects that social scientists always knew, but we as computer science don't, came out with this study, especially like some interesting insights in relation to the various nationalities that live in Ireland. I'll present a graph. So this box plot is showing something very, very interesting. And this came from a theory by a postdoc of international business. Now, my background is not business. I don't know about this stuff. That there is something called cultural distance. And Ireland's cultural distance with respect to Anglo-Saxons. Now, Anglo-Saxons would be people from the US, UK, Confucius Asians, people from China, Hong Kong, Vietnam, those Asians. Eastern Europeans would be Poland, Ukraine, Slovakia, countries like that. And Latin America, Brazil, Chile, that part of the world, a Middle Eastern region. So this cultural distance value, we made these clusters of countries based on cultural distance value derived from international business. Now, we see an interesting pattern here. If we would have done all the migrants together, maybe this wouldn't have not been so obvious. Some communities find it very hard to make friends that are native Irish. Native here, we refer to those who have been in Ireland, who are born Irish. So overall, what this is representing 4 would be that the survey question was, do you find it easy to make Irish friends? And strongly agree was 5, means you find it very easy. And strongly disagree was 1. So you see, strongly disagree was a higher number. So the Latin American and the Africans, they find their mean is the same, 4. So they find it harder. But within the Latin American ones, you see that even the lower quartile has a lower number. So they are struggling more. So there's wide variation in the Africans. Some Africans would find it easy, but overall the Latin Americans, and that makes sense. If you read the news articles in Ireland, you would see that a lot of the delivery drivers who are facing a lot of racism, they are from Latin America. It would add up with the data from social media, from the web. So that's a very interesting outcome of this project. And this one is an ongoing part. What we did here was that we gathered tweets of migrants and natives. They were manually tagged for who is a native and who is a migrant. The data set of this will be made publicly available, hopefully, because it's Twitter data and Twitter terms of service allows it. But it's still a work in progress, and when the findings will be published, then hopefully it will be released along with the data. So an interesting aspect is, so what this graph is showing is that I just used word embeddings on the tweets of migrants and natives. And then I applied k-means clustering to those words, and based on TSNE, reduction was applied, to visualize. Now, 2 of these clusters label, but the one with the label 0, the purplish one, and the one with the label 2, the greenish one, you would see that in the green one, there are a lot of migrants. And that one, label 2, is about NMH abortion. Now there's this whole controversy around Ireland's National Maternity Hospital. It's being given to a church called St. Vincent's, and a lot of natives seem concerned about it, but the migrants, not so much. They didn't tweet a lot about it. So this also is showing the topics that migrants talk about over their social media and natives talk about over the social media can tell the level to which there is an integration into the society. That's what we're trying to do via this project. So the whole idea of, this is the code. Hopefully I will be able to share it soon because the project will be, the data will be made available. But my whole point is that if you take up problems from humanities and social science and try to come up with data science methods, and Python has very, very effective tools like GenSim, word embeddings, NLTK. If you try to solve it with that, you'll get very, very interesting insights and ideas. And that's what's motivating the arts, humanities, and social science disciplines towards it. In fact, there's a whole new field called computational social science. So thank you.